Have you ever had the strange sensation, perhaps while walking alone down a long hallway or waking up in a room that is pitch black, that the world behind you has simply ceased to exist? We move through our lives with a deep, intuitive assumption that reality is solid. We believe that the chair you are sitting on, the walls of your room, and the moon hanging in the sky are real, physical objects that exist whether you are looking at them or not. We assume that the universe is a stage that was built long before we arrived and will remain long after we leave, a set of permanent furniture that does not care if it has an audience. But in the early 20th century, a group of physicists began to pull at a loose thread in the fabric of this assumption, and as they pulled, the entire tapestry of a solid, objective reality began to unravel. Tonight, we are going to descend into the basement of the universe. We are going to leave the world of galaxies and gravity behind and shrink down into the subatomic realm, where the rules of common sense vanish, and where we confront a ghost that seems to suggest that reality is not something we find, but something we create. To understand this ghost, we must first understand the emptiness of matter. Look at your hand. It looks solid. It feels firm. If you slap it against a table, it makes a sound. But this solidity is a magnificent illusion. If we were to take a microscope and zoom in on your skin, we would see cells. If we zoomed in on a cell, we would see molecules of protein and DNA. If we zoomed in on a molecule, we would see atoms. And this is where the picture changes. We are taught in school that an atom is like a tiny solar system, with a nucleus in the middle and electrons orbiting around it like little planets. But this model is misleading. If you were to blow up an atom to the size of a football stadium, the nucleus, the part that contains almost all the mass, would be a small marble sitting on the 50-yard line. And the electrons? They would be tiny gnats buzzing around the highest seats in the stands. Everything in between, the field, the rows of seats, the vast dome of the air, would be empty space. Nothingness. You are almost entirely made of empty space. The only reason your hand does not pass through the table is because the electrical fields of your atoms are repelling the electrical fields of the table's atoms. It is force, not matter, that you feel. But the quantum world is not just empty. It is undefined. In the 1920s, physicists like Niels Bohr and Werner Heisenberg began to realize that the subatomic particles that make up that tiny marble and those buzzing gnats do not behave like objects at all. They do not have a fixed position. They do not have a fixed speed. Until they are measured, they exist in a hazy cloud of probability. An electron is not a point in space. It is a smear of potential. It is here, and it is there, and it is everywhere in between, all at the same time. This concept, known as superposition, suggests that the fundamental building blocks of our reality are not things, but possibilities. This leads us to the most famous and most unsettling experiment in the history of science, the double-slit experiment. It is a test so simple that you can build it in a high school physics lab, yet its implications are so profound that they continue to baffle the greatest minds on Earth. Imagine you have a wall with two vertical slits cut into it. Behind that wall is a screen that records where particles land. Now, imagine you have a machine that fires tennis balls. If you fire tennis balls at the wall, some will bounce off, but some will pass through the slits. On the back screen, you will see two bands of marks directly behind the two slits. This is what we expect. Matter travels in straight lines. Now, let us shrink the experiment down. Instead of tennis balls, we fire electrons, tiny particles of matter. We fire them one by one. Logic dictates that we should get the same result, 2 bands of marks on the back screen. But when physicists actually do this, they see something impossible. They do not see 2 bands. They see an interference pattern, a series of many alternating bright and dark bands spread across the entire screen. This is the kind of pattern you get when waves of water crash into each other. If you drop 2 stones in a pond, the ripples overlap. Where 2 crests meet, the wave gets bigger. Where a crest meets a trough, they cancel each other out. The electrons, which are supposed to be solid particles of matter, are behaving like waves. They are passing through both slits at the same time, interfering with themselves, and landing on the screen as a pattern of probability. But here is the twist that shatters our understanding of the world. Physicists decided to be clever. They wanted to see which slit the electron was actually going through. So they placed a tiny detector, a measuring device, a mechanical eye, next to the slits to watch the electrons pass. They turned on the beam again. The detector beeped every time an electron went through the left slit or the right slit. But when they looked at the back screen, the interference pattern was gone. The beautiful, complex wave pattern had vanished. In its place were just 2 simple bands of marks. The electrons had stopped behaving like waves and started behaving like tennis balls. Let that sink in for a moment. The electrons knew they were being watched. The very act of observation changed the nature of reality. When no one was looking, the electron was a wave of infinite possibility, flowing through both doors at once. But the moment a conscious observer, or a proxy for one, asked the question, "Where are you?" the electron snapped into a single, defined position. It collapsed from a probability into a reality. This is known as the collapse of the wave function. It implies that the world out there is not fixed. It is a fluid, shimmering ocean of potential that only hardens into a solid rock when we turn our gaze upon it. This disturbed Albert Einstein deeply. He believed in a universe of strict cause and effect, a universe that existed independently of us. He famously asked a friend during a walk, "Do you really believe the moon is not there when you're not looking at it?" According to the strict interpretation of quantum mechanics, the answer is not a simple yes. The answer is that the moon exists as a probability wave, a quantum ghost, until it interacts with an observer. This debate culminated in the 1920s at the Solvay conferences, where the greatest physicists gathered to argue about the nature of reality. Einstein would come down to breakfast with a new thought experiment designed to prove that the universe was objective. And by dinner time, Niels Bohr would have found the flaw in Einstein's logic, defending the idea that the observer is an inseparable part of the system. Bohr's view, known as the Copenhagen interpretation, suggests that there is no deep reality. There is only the interaction between the measuring device and the particle. There is no quantum world, Bohr famously said. There is only an abstract quantum physical description. This is a dry way of saying something mystical, that the universe requires a witness. Without a witness, the drama of existence is just a script that has never been performed. It remains in the realm of the abstract. This brings us back to the idea of the universe as a simulation, or perhaps more poetically, a dream. In a video game, the computer does not render the entire world at once. That would be a waste of processing power. It only renders the room that the player is standing in. The mountains in the distance are just flat images until you walk towards them. Is it possible that the universe works on a similar principle of efficiency? does it only render the particles that are currently being observed. But the mystery goes deeper than just observation. It touches on connection. There is another phenomenon in quantum mechanics that Einstein called spooky action at a distance. Today, we call it quantum entanglement. It happens when two particles interact and become linked. Their wave functions merge. They become part of the same mathematical system. If you take these two entangled particles and separate them, send one to the other side of the room, or the other side of the planet, or the other side of the universe, they remain connected. If you measure the first particle and find that it is spinning up, the second particle will instantly, faster than the speed of light, decide to spin down. It is as if they are communicating instantly across the void. Or, more likely, it is as if the space between them does not actually exist. Entanglement suggests that separation is an illusion. We look at the universe and see separate objects, stars, planets, trees, people. We see distance. We see empty space separating us from the things we love. But underneath the surface, in the deep quantum code, everything that has ever interacted is still connected. And remember, in the Big Bang, all matter was crushed into a single point. Everything was interacting. Everything was entangled. This means that, fundamentally, every particle in your body is entangled with every particle in the farthest galaxy. The universe is not a collection of separate parts. It is a single, vast, interconnected web. When you look at a star, you're not just seeing light that has traveled for millions of years. You're interacting with a part of yourself that has been flung across the cosmos. This paints a picture of the universe that is far more intimate than the cold, mechanical clockwork of Newton. It is a universe where mind and matter are not two separate things, but two sides of the same coin. The physicist John Wheeler, who gave us the term black hole, proposed that the universe is built on information. He coined the phrase "it from bit." He meant that every particle, every force, every it in the universe ultimately derives its existence from the answers to yes or no questions, bits of information posed by the observer. We are not just watching the show, we are writing the script as we go along. So, what does this mean for you lying in the dark, listening to this story? It means that your consciousness is not a trivial accident. It is the mechanism by which the universe becomes real. You are the renderer. You are the lighthouse beam that sweeps across the dark ocean of probability, turning the potential into the actual. Without you, without your mind to collapse the wave functions, the universe might just be a haze of ghosts, a silent symphony of maybe. This can be a terrifying thought. It places a burden of reality on your perceptions, but it is also a deeply comforting one. It means you are never truly isolated. The feeling of loneliness is a biological trick, a survival mechanism. In the quantum realm, you are woven into the fabric of everything. You are entangled with the bedrock of the earth, with the air you breathe, and with the stars you cannot see. The silence of the night is not the silence of emptiness. It is the silence of a held breath waiting for you to exhale. Think about the implications of this for a moment. If observation creates reality, what happens when we observe ourselves? What happens when the mind turns its gaze inward? We spend so much time looking out, at screens, at faces, at landscapes. We are constantly collapsing the wave functions of the world around us, but rarely do we stop to collapse the wave function of the self. In meditation, in deep contemplation, we stop creating the world for a moment. We let the waves ripple out. We let the boundaries blur. And in those moments, people often report a feeling of oneness, of dissolving into the light. Perhaps this is not a hallucination. Perhaps this is a direct experience of the quantum reality, a momentary return to the superposition of the universe before the collapse. The science of quantum mechanics is over 100 years old, yet we are still struggling to accept what it tells us. We cling to the idea of a solid, independent world because it feels safer, it feels predictable. But the truth is far stranger and far more beautiful. The world is soft. It is malleable. It is waiting for interaction. It is a partnership between the observer and the observed. As we move forward in this journey, we must carry this knowledge with us. We are not just walking through a universe. We are walking through a mind. And if space is an illusion created by entanglement, what about time? We feel time flowing like a river, carrying us from the past into the future. We remember yesterday, but we cannot remember tomorrow. We feel trapped in the now. But the equations of physics do not distinguish between the past and the future. In the fundamental laws, time is symmetric. It can flow forward or backward with equal ease. So, why do we perceive it as a one-way street? Why does the arrow of time only fly in one direction? Is time, like solidity, just another persistent illusion? To understand this, we must look at the concept of disorder. We must look at why cups break but never unbreak. We must look at the force that drives the universe from order into chaos, and ask if our consciousness is just a surfer riding the wave of entropy. The next chapter of our story will take us into the machinery of the clock. We will dismantle the seconds and the hours to find out what time really is, and whether it is possible that, in the mind of the universe, everything that has ever happened and everything that will ever happen is happening right now. But for tonight, stay with the quantum ghost. Look at the shadows in your room. Know that in the dark, where your eyes cannot see, the particles are dancing in a cloud of infinite possibility. Know that by simply being there, by simply being aware, you are pinning them down, anchoring them to reality. You are the witness that the universe needs. You are the bridge between the dream and the waking world. Let yourself drift into that soft, undefined space of sleep where the wave function of your own mind can expand, untethered, into the cosmos. Have you ever sat by the bank of a wide, slow-moving river, watching the water drift endlessly downstream, and felt a strange, melancholic connection between the current and your own life? We are creatures of time. We live in the flow. We feel the seconds ticking away in the beat of our hearts. We see the years accumulating in the lines on our faces, and we carry the weight of the past in our memories while looking anxiously toward the fog of the future. We are born, we grow, we age, and we die. The arrow of time seems to be the most fundamental, undeniable fact of our existence. It moves in one direction only, forward. You can remember your childhood, but you cannot remember your old age. You can turn a fresh egg into an omelet, but you can never, no matter how hard you try, turn an omelet back into a fresh egg. This one-way street is what gives our lives their narrative structure. It is what gives us cause and effect, regret and hope. But here is the secret that physicists discuss in hushed tones when the equations don't add up. Deep down, in the fundamental laws of the universe, there is no river, there is no flow, and the distinction between the past, the present, and the future may be nothing more than a stubborn, persistent illusion created by the limitations of your own mind. Tonight, we are going to stop the clock. We are going to step out of the river and climb up the bank to look at the landscape of time as it really is. A frozen, crystal ocean where every moment that has ever happened, and every moment that will ever happen, exist together in a single, eternal now. To understand why time is such a mystery, we have to look at the rule book of the cosmos. The laws of physics, from Newton's laws of motion to Schrödinger's equation of quantum mechanics, are almost entirely time-symmetric. This means that the equations work equally well, running forward or backward. If you filmed a planet orbiting a star and played the movie in reverse, the orbit would still obey the laws of gravity perfectly. If you filmed two billiard balls colliding and played it backward, the physics would still be valid. At the microscopic level, the universe does not care about direction. An atom does not know if it is yesterday or tomorrow. So, if the fundamental building blocks of reality have no arrow of time, where does the arrow come from? Why do we never see a shattered teacup reassemble itself and jump back onto the table? Why do we never see smoke swirling back into a chimney to become a log of wood? The answer lies in a concept that is as beautiful as it is tragic: entropy. In the 19th century, an Austrian physicist named Ludwig Boltzmann stared into the chaos of the Industrial Revolution, steam engines, burning coal, dissipating heat, and found the mathematical definition of disorder. He realized that the reason things fall apart is simply a matter of probability. Imagine you have a deck of cards arranged in perfect order from ace to king in every suit. This is a state of low entropy, high order. There is only one way the deck can be perfect. Now, throw the deck into the air. When the cards land, they will be mixed up. Why? Not because a force pushed them into chaos, but because there are millions upon millions of ways for the cards to be disordered, and only one way for them to be ordered. It is simply much, much more likely for the universe to be messy than for it to be tidy. This is the second law of thermodynamics. In a closed system, entropy, the measure of disorder, always increases. This law is the only thing in physics that distinguishes the past from the future. The past is the direction of lower entropy. The future is the direction of higher entropy. We are riding a wave of disorder that began 13.8 billion years ago. At the moment of the Big Bang, the universe was in a state of incredibly low entropy. It was a tight, hot, uniform knot of energy. It was perfectly ordered. Since that moment, the universe has been exploding outward, expanding, cooling, and getting messier. Stars burn fuel and scatter waste heat. You eat food, ordered chemical energy, and dissipate it as body heat. The breaking of the teacup is just the universe doing what it does best, moving from the unlikely state of being a cup to the likely state of being a pile of ceramic shards. We are not moving through time. We are moving through probability. We are sliding down the slope of statistical likelihood. But this explains the flow of heat, not the flow of time itself. To understand the structure of time, we must turn to Albert Einstein. Before Einstein, we thought time was a universal clock ticking away in the background, the same for everyone, everywhere. Isaac Newton believed that absolute, true, and mathematical time, of itself and from its own nature, flows equably without relation to anything external. But in 1905, Einstein shattered this clock. With his theory of special relativity, he proved that time is flexible. It is elastic. The rate at which time passes depends on how fast you are moving. If you were to get into a spaceship and travel at 99% of the speed of light, time for you would slow down to a crawl relative to the people you left back on Earth. You might travel for what feels like a year, only to return and find that a century has passed for everyone else. This is not just a theory. It has been proven by experiments. We have flown atomic clocks on airplanes and watched them fall out of sync with clocks on the ground. Your GPS satellites have to be programmed to account for the fact that time flows differently for them up in orbit than it does for us down here. If they didn't, your map app would fail within minutes. But Einstein went further. He showed that space and time are not separate things. They are woven together into a single four-dimensional fabric called space-time. And just as we think of space as existing all at once, New York and Tokyo and the moon and Mars all exist right now, even if you are not there. Relativity suggests that time also exists all at once. This leads to the concept of the block universe. Imagine a loaf of bread. This loaf represents the entire history of the universe. One end of the loaf is the Big Bang. The other end is the heat death of the cosmos. Every slice of the bread represents a specific moment in time. But the loaf exists as a whole object. In the block universe theory, the past, the present, and the future are all equally real. The dinosaurs are still roaming the earth in their slice of the space-time loaf. Your birth is still happening. Your death already exists. The feeling that we are moving through the slices one by one is an illusion of human consciousness. It is like a spotlight moving across a dark stage. The actors and the sets are all there in the dark, waiting. But we only see what is illuminated by the now. Why does this happen? Why do we feel a now if all of time exists at once? It may be because our brains work on entropy. We consume energy to create memories. The process of laying down a memory increases the disorder in your brain and the environment. Because entropy increases in one direction, our brains are wired to record information in that direction. We have records of the past, memories, photographs, fossils, but we have no records of the future. This asymmetry creates the feeling of a flow. We are biological machines designed to navigate the entropy gradient, and so we perceive the static block of space-time as a moving river. But to a hypothetical observer standing outside the universe, looking at the whole four-dimensional block, there is no motion. There is just a vast, intricate, frozen sculpture of events. This perspective is dizzying, but it can also be profoundly comforting. We tend to mourn the past. We feel a deep sense of loss for the moments that are gone, the childhood summers, the laughter of friends who have passed away, the versions of ourselves that no longer exist. We think of the past as something that has been destroyed, erased by the passage of time. But if the block universe is real, then nothing is ever truly lost. Those moments are still there. They are indelible parts of the structure of reality. Your first steps, your first kiss, the quiet Sunday mornings of your youth, they are fixed in the amber of space-time forever. They are as real as the chair you are sitting on right now. They are just at a different coordinate. To say they are gone is like standing in Paris and saying that London doesn't exist because you can't see it. London is just over there. The past is just back then. Einstein himself found great solace in this idea. When his lifelong friend Michele Besso died, Einstein wrote a letter to Besso's family that has become famous among physicists. He wrote, "Now he has departed from this strange world little ahead of me. That means nothing. People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion." He was not offering a religious platitude. He was stating a scientific conviction. In the physics of the block universe, death is not the end of existence. It is simply the boundary of a specific space-time coordinate. The life that was lived exists eternally within those boundaries. But what about the future? If the future already exists in the block, does that mean we have no free will? Is the script already written? This is where the mystery deepens, and where quantum mechanics comes back to haunt us. Remember the wave function from the last chapter, the cloud of probability? Some physicists believe that the block is not a single, solid loaf of bread, but a branching tree. This is the many worlds interpretation of quantum mechanics. In this view, every time a quantum event has multiple possible outcomes, the universe splits. In one branch, the electron goes left. In another, it goes right. In one branch, you decided to listen to this story. In another, you went to sleep early. If this is true, then the future is not a single fixed path, but an infinite garden of forking paths. All the possibilities exist, but we only experience one path at a time. We navigate the multiverse moment by moment, slicing our way through the probability space. But even in this view, the past versions of you, the ones who made different choices, the ones who lived different lives, are still there, inhabiting their own branches of the great cosmic tree. The universe is much more crowded than we think. It is filled with all the things that happened and all the things that could have happened, all coexisting in a vast, timeless superstructure. Let us return to the riverbank for a moment. Imagine that you can lift yourself up higher and higher until the river looks like a silver ribbon winding through the land. From this height, you can see the source of the river in the mountains, and you can see the delta where it meets the sea. You see the whole river at once. The water at the source is not gone just because the water at the mouth is flowing. It is all one system. This is the view of the universe that physics invites us to hold. It asks us to detach from the anxiety of the ticking clock and float in the eternity of the structure. This realization changes how we look at our own lives. We are often in a rush, constantly leaning forward into the next moment, the next task, the next year. We treat the present moment as nothing more than a bridge to get to the future. But if the future is just another coordinate, and the past is just another coordinate, then the hierarchy of time collapses. This moment, right here, right now, is not fleeing. It is an eternal location. The sensation of breath entering your body, the hum of the room, the feeling of gravity. This is a permanent feature of the cosmos. You are painting this moment onto the canvas of space-time, and once the paint dries, it can never be removed. So, why not paint it with peace? Why not paint it with awareness? If we are trapped in the amber of the block universe, we might as well make our section of the amber glow. The Japanese have a word, mono no aware, which translates to the pathos of things, or a sensitivity to ephemera. It is the bittersweet realization that things are beautiful precisely because they are temporary. But physics adds a twist. They are temporary in our experience, but eternal in existence. The cherry blossom falls, and in our timeline, it rots. But in the space-time block, the blossom is forever falling, forever catching the light, forever perfect. As you lie there, feeling the stillness of the night, try to expand your mind to encompass this four-dimensional reality. Imagine your life not as a fleeting spark in the dark, but as a long, luminous worm glowing through the block of the universe. One end is your birth, the other is your death, and the whole glowing strand is you. You are a biological sculpture in time, and you are connected to the strands of everyone you have ever known, weaving a complex braid through history. The universe is a tapestry of these braids, a fabric of woven lives, static and silent and beautiful. But there is a force that warps this fabric. There is a presence that bends the straight lines of time and twists the block of space. We have talked about gravity as a force, but Einstein taught us that it is something far stranger. Gravity is geometry. It is the curvature of the stage itself, and in the deepest wells of this curvature, where the fabric is stretched to its breaking point, time does not just slow down, it stops. The river freezes completely. In the next chapter of our journey, we will travel to the edge of the abyss. We will visit the event horizon of a black hole, the place where the known universe ends and a new, impossible reality begins. We will ask what happens when you fall off the edge of the map, and whether the monsters lurking in the dark are actually the architects of the galaxies. For now, let the river of time slow down. Let the current settle. You are not running out of time. You are made of time. You are a permanent resident of the cosmos. The anxiety of the ticking clock is a story your brain tells you to keep you moving, but you don't have to listen to it tonight. Tonight, you can rest in the eternal now. You are safe in the block. You are held in the crystal. Sleep, and let the universe keep watch over your moment in the sun. Have you ever stood at the edge of a great cliff, looked down into the swirling mist below, and felt a strange, magnetic pull in the pit of your stomach? It is not just the fear of falling. It is something deeper, a primal fascination with the abyss. We are creatures of the light, born under the warmth of a yellow star, adapted to see in the narrow band of the electromagnetic spectrum that penetrates our atmosphere. But the universe is mostly dark. The light we cherish is a rare exception, a fragile candle flickering in a vast cold cathedral, and in the deepest shadows of that cathedral, lurking in the centers of galaxies and the graveyards of dead stars, are objects so extreme, so terrifying, and so magnificent that they break the very laws of physics that govern our lives. They are the dragons on the maps of the cosmos, the places where space flows like a waterfall and time freezes into crystal. Tonight, we are going to journey to the event horizon. We are going to stare into the eye of the black hole, and we are going to discover that these cosmic monsters are not simply engines of destruction, but the architects of our existence. To understand the black hole, we must unlearn what we think we know about the ground beneath our feet. We think of gravity as a force, a tether that holds us to the earth. But as we touched upon before, Albert Einstein taught us that gravity is actually geometry. Imagine a trampoline, pulled tight. If you roll a marble across it, it moves in a straight line. But if you place a heavy bowling ball in the center, the fabric curves. The marble no longer moves straight. It curves around the bowling ball. It is not being pulled by a mysterious force. It is simply following the shape of the canvas. Now, imagine that the canvas is three-dimensional space, and the bowling ball is a star. This is the fabric of space-time. Massive object tells space how to curve, and space tells matter how to move. But there is a limit to how much you can stretch the fabric before it tears. Most stars are balanced. Our sun is a constant war between two mighty forces. Gravity is trying to crush the star inward, trying to pull all that gas into a single point. But the nuclear fire in the core, the fusion of hydrogen into helium, creates an outward pressure that holds the star up. It is a stalemate that lasts for billions of years. But eventually, the fuel runs out. The fire dies. And when the fire dies, gravity wins. For a star like our sun, the collapse is gentle. It becomes a white dwarf, a glowing ember the size of Earth. But for the true giants of the universe, stars 10, 20, or 50 times more massive than the Sun, the collapse is a catastrophe. When the fuel is gone, the core collapses with such violence that it triggers a supernova, an explosion that can outshine an entire galaxy. But what is left behind? If the core is heavy enough, there is no force in the universe strong enough to stop the collapse. The atoms are crushed, the electrons are smashed into protons, the neutrons are squeezed until they touch, and then even the neutrons give way. The star shrinks past the point of no return. It punches a hole in the fabric of reality. It becomes a singularity. This is where the story becomes truly mind-bending. A black hole is not a solid object. It is not a planet made of dark rock. It is a region of space where gravity has become so intense that the escape velocity exceeds the speed of light. Since nothing can travel faster than light, nothing can escape. Not matter, not radiation, not information. It is a one-way door to the unknown. Surrounding the singularity is the event horizon, the boundary of the shadow. It is the point of no return. Crossing the event horizon is like going over the edge of a waterfall in a boat. Upstream, you can paddle against the current and escape. But once you cross the lip, the water is falling faster than you can paddle. Inside the horizon, space itself is falling toward the singularity faster than light. Let us imagine for a moment that you are a brave astronaut traveling toward a black hole. Let us choose the supermassive monster at the center of our own Milky Way, known as Sagittarius A star. It contains the mass of 4 million suns. As you approach, you would not see a black circle. You would see a ring of fire. This is the accretion disk, gas and dust that has been caught by the black hole's gravity and is spiraling inward like water down a drain. As the gas falls, it speeds up to a significant fraction of the speed of light. Friction heats it to millions of degrees. It glows with a fierce X-ray brilliance. But in the center of this swirling maelstrom, there is a perfect spherical shadow, a silhouette against the fire. This is the shadow of the event horizon. As you get closer, the gravity begins to warp the light from the stars behind the black hole. The sky begins to bend. Stars smear out into arcs and circles, creating a funhouse mirror effect known as gravitational lensing. The universe looks like it is being viewed through a crystal ball. And then you experience the distortion of time. This is the phenomenon of time dilation predicted by Einstein and proven by our clocks, taken to its absolute extreme. Gravity slows time down. The stronger the gravity, the slower time flows. As you get closer to the horizon, to an observer watching you from a safe distance, you would appear to slow down. Your movements would become sluggish. Your voice, sending radio messages back to Earth, would drop in pitch, becoming deeper and deeper, stretching out into silence. The light reflecting off your spaceship would shift to the red, fading into infrared, then radio waves, until you simply faded from view. To the outside universe, you would never actually cross the horizon. You would just freeze there, trapped forever on the edge of forever, a ghostly image fading into the dark. But from your perspective, everything is different. You would not feel yourself slowing down. You would look at your watch, and the second hand would be ticking at its normal rhythm. Your heart would beat at its normal pace. You would cross the horizon without a bump, without a flash, without any sign that you had left the known universe behind. But if you looked back at the universe you were leaving, you would see something breathtaking. Because time outside is moving faster than time inside, you would see the external universe speeding up. You might see stars born and die in seconds. You might see galaxies rotate like spinning tops. You might see the entire future of the cosmos playing out. In fast forward, a stream of light cascading into the hole behind you. You are entering a region of space-time that is separated from the rest of reality. You are now in a private universe, cut off from the timeline of human history. Inside the horizon, the rules of geometry flip. In our world, we can move freely through space, left, right, forward, backward, but we are forced to move forward through time. We have no choice but to go to tomorrow. Inside a black hole, space and time swap roles. The radial direction, the path toward the center, becomes your time. You can no more stop falling toward the singularity than you can stop tomorrow from arriving. The center is no longer a place. It is a future event. It is a date on your calendar, and it is waiting for you with the inevitability of midnight. At the center lies the singularity. According to general relativity, this is a point of infinite density and zero volume. It is a place where the curvature of space becomes infinite. It is a mathematical error in the code of the universe. Physicists do not believe that singularities are actually infinite. Infinity is usually a sign that our theories have broken down. It suggests that deep inside the black hole, quantum mechanics must take over. Perhaps the star does not shrink to a point. Perhaps it shrinks to a Planck star, a tiny, dense nugget of quantum foam where the forces of gravity and the nuclear forces reach a new exotic balance. Or perhaps, as some daring theorists suggest, the singularity is a bridge, a wormhole, a tunnel that leads to another region of space, or even another universe entirely. This brings us to one of the most beautiful and controversial ideas in modern cosmology, the idea that universes reproduce. We talked about this briefly as a form of natural selection, but let us look at the mechanism. If a black hole pinches off a piece of space-time, creating a closed bubble, what happens inside that bubble? Maybe it expands. Maybe the laws of physics inside reset. To an observer inside that new bubble, the expansion would look exactly like a Big Bang. It would look like a universe springing from nothing. If this is true, then our own Big Bang might have been the result of a star collapsing in a parent universe. We might be living inside the event horizon of a higher dimensional black hole. And every black hole in our own galaxy might be the seed of a new universe, hidden from us forever by the veil of the horizon. This transforms the black hole from a monster into a mother. It suggests that death and birth are intimately linked in the cosmos. The death of a star creates the condition for a new reality. The destruction of matter creates the possibility of new space. It is a cycle of renewal that operates on scales we can barely comprehend. But we do not need to speculate about other universes to see the creative power of black holes. We can see it right here, in our own backyard. For a long time, astronomers thought black holes were rare. But now we know that there is a supermassive black hole at the center of almost every large galaxy. And these giants are not just sitting there. They are conductors of the galactic orchestra. The energy released by gas falling into a black hole can power massive jets of particles that shoot out for thousands of light years. These jets stir the gas of the galaxy. They heat it up. They prevent it from cooling down too fast. By doing this, the black hole regulates the rate of star formation. If the black hole were not there, the galaxy might have burned through all its gas too quickly, creating a brief fireworks show followed by eternal darkness. The black hole acts as a thermostat, keeping the galaxy alive and active for billions of years. It allowed our sun to be born at the right time, with the right elements. We owe our existence to the monster in the middle. There is a profound comfort in this. We tend to fear the dark, the void, the places where we lose control. But the black hole teaches us that the dark is necessary. It creates the structure. It holds the galaxy together. The gravitational pull of Sagittarius A star helps to anchor the spiral arms of the Milky Way, creating the stable, flat disk where our solar system resides. We are orbiting the abyss, and that orbit is what keeps us safe. We are dancing around the drain, but the dance is what we call life. And even black holes are not eternal. In the 1970s, the physicist Stephen Hawking made a discovery that shocked the scientific world. He applied quantum mechanics to the event horizon and found that black holes are not truly black. They glow. They emit a faint radiation, now called Hawking radiation. Through a strange quantum process involving virtual particles popping in and out of existence near the horizon, the black hole slowly loses energy. It evaporates. Over timescales that are staggering, numbers with nearly 100 zeros, the black hole will shrink and eventually disappear in a final flash of light. This means that even the most permanent, indestructible objects in the universe are temporary. They too are subject to the flow of time. They too will return their energy to the cosmos. This leads to the information paradox. If a black hole evaporates, what happens to the stuff that fell in? If you throw a book into a black hole, the information in that book, the words, the ideas, the order of the pages, is swallowed. If the black hole disappears, is that information lost forever? Quantum mechanics says information can never be destroyed. General relativity says the black hole destroys it. This conflict is the biggest battlefield in modern physics. But recent breakthroughs suggest a resolution that sounds like magic. The information is stored on the surface. It is encoded in the hologram of the event horizon. Imagine a library burning down. The books are destroyed, turned into ash and smoke. But if you could capture every photon of light, every particle of ash, and every molecule of smoke, you could, in theory, reconstruct the books. Hawking radiation might be that smoke. It might carry the subtle imprint of everything the black hole ever consumed. This suggests that the universe is a kind of hologram, where the three-dimensional reality we experience is a projection of two-dimensional information stored on the boundary of space. You, me, the stars, the galaxies. We might be ghostly projections of a code written on the edge of the universe. As you lie in the quiet of your room, think about the information that makes you who you are. The memories, the personality, the consciousness. Physics suggests that this information is the most fundamental thing in existence. It cannot be deleted. It can be scrambled. It can be hidden inside a black hole. It can be radiated away as heat. But it remains woven into the fabric of reality. You are a sentence written in the book of the cosmos, and the ink never fades. The black hole is the ultimate test of our courage to know. It challenges us to look at the place where the map ends and not turn away. It asks us to trust that even in the singularity, even in the breakdown of all laws, there is a logic and a beauty. It reminds us that our perspective is limited. We see a whole. The universe sees a seed. We see an end. The universe sees a bridge. We see darkness. The universe sees the gravitational anchor of home. The journey into the black hole is a journey into the limits of knowledge, but it is also a journey into the power of the human mind. We have never visited a black hole. We have never sent a probe. And yet, sitting on this small blue rock, using nothing but mathematics and telescopes, we have figured out that they exist. We have photographed them. In 2019, humanity saw the first image of the black hole in the galaxy M87, a glowing orange donut of light surrounding a perfect dark center. We looked the monster in the eye, and we did not blink. We saw the verification of Einstein's dreams. We saw the proof that the human mind can reach out across 55 million light years and understand the most extreme environment in nature. So do not fear the deep night. The black holes are out there, silent and heavy, sculpting the galaxies, holding the time, keeping the secrets. They are the guardians of the mysteries we are just beginning to unlock. And as we drift further into sleep, we leave the frozen time of the event horizon behind and turn our attention to something even more pervasive, something that touches us every single day, but remains completely misunderstood. We are going to look at the light itself. We are going to ask what a photon experiences, and we will discover that for light, time does not exist at all. We will see that the light hitting your eye from a star has not aged a single day since it left the surface of that sun. We are made of light, held together by gravity, and the dance between the two is the story of everything. Rest now, safe in the gravity of the earth, anchored by the black hole at the heart of the Milky Way, spinning gently in the great web of the cosmos. The universe is holding you. The dark is not empty. It is full of potential. It is full of the future waiting to be born. Sleep, and let the gravity of your dreams pull you inward. Have you ever closed your eyes on a warm summer afternoon and turned your face toward the sun? Even through your closed eyelids, you can feel the heat and see the red glow of the light washing over you. It feels immediate. It feels intimate. It feels like the sun is touching you right now, in this very second. But that feeling is a beautiful lie. The light that is warming your skin is a ghost. It is a messenger from the past. The sun is 93 million miles away, a distance so vast that it takes light, the fastest thing in the universe, 8 minutes and 20 seconds to cross it. If the sun were to suddenly vanish, to simply blink out of existence right now, you would not know it. You would continue to feel its warmth, see its light, and orbit its gravity for another 8 minutes. You would be living in a reality that no longer exists, happily unaware that the source of your life has died. This delay, this gap between the event and the perception, is a fundamental feature of our universe. We live in a cosmos where now is a local illusion, and everything we see, from the lamp in the corner of the room to the stars in the night sky, is an image from the past. Tonight, we are going to leave the world of matter behind completely. We are going to shed our weight, shed our mass, and become pure energy. We are going to ride a beam of light across the void, and we are going to discover that from the perspective of a photon, time and space do not exist at all. To understand light, we must understand the speed limit of reality. In our daily lives, speed is relative. If you are driving down the highway at 60 miles per hour and a car passes you doing 70, it seems to be moving away from you at 10 miles per hour. But light does not play by these rules. In the late 19th century, physicists discovered something that bothered them deeply. No matter how fast you move, no matter how fast you chase a beam of light, it always moves away from you at exactly the same speed. You could be standing still, or you could be flying in a rocket ship at 99% of the speed of light. And if you measured a laser beam passing you, you would both get the exact same number. 186,282 miles per second. this number, known as c, is not just the speed of light. It is the speed of causality. It is the maximum speed limit of the universe. It is the speed at which information can travel. It is the tick rate of the cosmic processor. Nothing with mass can ever reach it, and nothing without mass can ever go slower than it. But the speed of light is not just a limit. It is a horizon. Because light takes time to travel, when we look out into the universe, we are looking back into time. When you look at the moon, you are seeing it as it was 1.3 seconds ago. When you look at Jupiter, you are seeing it as it was 35 minutes ago. When you look at the nearest star to our sun, Proxima Centauri, you are seeing light that left 4 years ago. You are seeing a version of that star that is 4 years old. And when you look at the Andromeda Galaxy, the faint smudge of light visible to the naked eye on a clear night, you are looking at light that has been traveling for 2.5 million years. That light left its home before modern humans walked the earth. It traveled through the intergalactic void while ice ages came and went, while civilizations rose and fell, while you were born and grew up, only to end its journey tonight, hitting the back of your retina. We are trapped in a bubble of the past. We can never see the universe as it is right now. We can only see the history of the universe cascading down upon us. But this is the view from the outside. This is how we perceive light. The true wonder begins when we ask, what does the universe look like to the light itself? Imagine for a moment that you could transform into a photon. Imagine you could shed your mass and accelerate to that magical speed of 186,000 miles per second. Einstein's theory of special relativity tells us that as you move faster, time slows down. If you travel at 90% of the speed of light, a year for you might be 2 years for the people back on Earth. At 99%, a year for you is 7 years for Earth. But as you get closer and closer to the speed of light, the stretching of time becomes infinite. At exactly the speed of light, time stops completely. This means that for a photon, there is no time. A photon does not experience the passage of seconds or minutes or years. From the perspective of a photon created in the heart of a distant star in the Andromeda Galaxy, the journey does not take 2.5 million years. It takes 0 time, 1 moment. It is being born in the fusion reaction of a star, and in the exact same instant, it is being absorbed by your eye. To the photon, the emission and the absorption are the same event. It does not experience the vast, cold emptiness of the intergalactic void. It does not experience the distance. According to relativity, at the speed of light, length contracts to 0. The entire universe in the direction of travel shrinks to a single point. So, for light, the universe is not a vast, empty place. It is a singularity of connection. Every point in the universe that can communicate with light is touching every other point directly. The photon is the bridge that collapses space and time into a single moment of here and now. Think about the implications of this. The light warming your face from the sun thinks it is still touching the sun. The light form, the Big Bang, the cosmic microwave background radiation that fills every cubic centimeter of space, has been traveling for 13.8 billion years from our perspective. But for those ancient photons, the Big Bang is happening right now in the same instant that they are touching your skin. We live in a universe of deep time and vast distance, but the light that illuminates us lives in a universe of instant immediacy. It weaves the cosmos together into a tapestry where everything is connected by threads of 0 time. But the journey of light is not always easy. Let us go back to the sun. The light you see today began its life in the core of our star, a place of unimaginable crushing pressure and a temperature of 15 million degrees. In this hellish forge, hydrogen atoms smash together to create helium, releasing a burst of energy, a gamma-ray photon. This tiny packet of light wants to fly out into the universe at the speed of light. But the core of the sun is so dense, so packed with protons and electrons, that the photon can only travel a tiny fraction of an inch before it crashes into something. It bounces. It is absorbed and re-emitted, scattered in a random direction. It might go left. It might go right. It might go back down toward the center. This is known as the drunkard's walk. The photon bounces around inside the sun, trapped in a maze of matter, for a very long time. It can take anywhere from tens of thousands to hundreds of thousands of years for that single photon to stumble its way from the core to the surface. It is a long, slow struggle against the density of the star. But finally, after eons of imprisonment, the photon reaches the photosphere, the surface of the sun. Suddenly, the path is clear. There is nothing in front of it but the vacuum of space. It spreads its wings, accelerates to its full cosmic speed, and races toward the Earth. That 8-minute flight is just the final sprint, after a marathon that lasted longer than the history of human civilization. The sunlight you see is ancient. It is old energy, born in a time before history, finally finding its freedom and landing on your face. And what happens when it lands? This is where the physics of light becomes the biology of life. We are creatures of light. The entire biosphere of Earth is a machine designed to catch photons and store their energy. A plant leaf is a solar panel. Inside the chloroplasts, a photon hits a molecule of chlorophyll and knocks an electron loose. This tiny kick of energy is captured, stabilized, and used to build sugars out of carbon dioxide and water. The plant is trapping the sunlight, freezing the energy of the star into chemical bonds. When you eat an apple or a piece of bread, you are unlocking that stored sunlight. The energy that powers your muscles, the energy that fires the neurons in your brain, allowing you to listen to this story, is literally released sunlight. You are eating the sun. You are powered by the nuclear fusion of a star 93 million miles away. But the connection goes deeper. Look at your hand again. It is made of atoms, protons, neutrons, electrons. Einstein's most famous equation, E equals mc squared, tells us that energy and mass are the same thing. Mass is just concentrated energy. Matter is just frozen light. In the very early universe, moments after the Big Bang, the cosmos was a soup of pure energy, pure radiation. As it cooled, some of that energy condensed into matter. The particles that make up your body are essentially light that has been slowed down, trapped in a gravitational dance, and given solidity. You are not just observing the light. You are made of it. You are a construct of the same stuff that shines from the stars, just woven into a different pattern. This is why we are drawn to the light. It is our source. It is our substance. And it is our primary way of knowing the universe. Almost everything we know about the cosmos comes to us via light. We cannot touch the stars. We cannot hear them. But we can catch their light. And in that light, we find their secrets. By passing starlight through a prism, we can split it into a rainbow, a spectrum. And in that spectrum, we see dark lines, barcodes that tell us what the star is made of. We can detect oxygen, carbon, iron, and gold in objects that are billions of light years away. The light carries information. It carries the fingerprint of its origin. A photon is not just a packet of energy. It is a packet of data. The universe is constantly broadcasting its autobiography in all directions, writing its history in beams of radiation that cross the void to tell us who we are and where we came from. Consider the light of the stars you cannot see. Our eyes are tuned to a very narrow band of the spectrum, the visible light that penetrates our atmosphere and is output by our sun. But the universe is shining in colors we cannot imagine. There are radio waves, huge wavelengths as big as mountains, emitted by cold gas clouds and spinning black holes. There are microwaves, the fading echo of the Big Bang. There are infrared waves, the heat of newborn stars glowing in their dusty nurseries. There are ultraviolet waves, X-rays and gamma rays, the screams of violent explosions and crashing neutron stars. The sky is ablaze with this invisible fire. If you could see in radio waves, the night sky would not be dark. It would be glowing with the bright, strange shapes of magnetic fields and ancient jets. We are blind to most of the show, but our machines, our telescopes, have opened these new eyes for us. They have revealed a universe that is far more dynamic, far more violent, and far more complex than the silent, twinkling canopy we see with the naked eye. But even with all our telescopes, even with our understanding of the spectrum, there is a limit. There is a wall we cannot see past. Because the universe is 13.8 billion years old, and because light travels at a finite speed, there is a cosmic horizon. We can only see things whose light has had enough time to reach us since the beginning of time. If there is a galaxy beyond that horizon, its light is still on its way. It has not reached us yet. We are inside a bubble of information, the observable universe. Beyond that bubble, there is likely more universe, perhaps infinite universe, but we are forever cut off from it. The light from those distant regions is trying to reach us, racing across the dark, but the space between us is expanding. In the far future, the expansion of the universe will stretch space so fast that the light from distant galaxies will never reach us. They will fade away. They will slip behind the horizon of causality. We live in a privileged time, a time when the sky is full of information. In the distant future, the sky will go dark, the galaxies will disappear, the evidence of the Big Bang will fade. Future civilizations might look up and see only their own galaxy, alone in an infinite, empty void, with no way of knowing the grand history that we are exploring tonight. So, treasure the light. Treasure the photons that are hitting your eyes right now. Each one is a traveler that has crossed an ocean of nothingness to bring you a message. Each one is a witness to a specific event in the past. When you look at a star, you are entangling yourself with it. You are the destination of a journey that began before you were born. You are completing the circuit. The star emits, and you receive. In that moment of reception, in that tiny chemical reaction in your retina, the star achieves a kind of immortality. Its energy becomes your perception. Its history becomes your memory. And what about your own light? You are warm. You are radiating infrared light right now. Photons are streaming off your body, traveling out into the room, absorbed by the walls. But some of them might escape. If you are outside, looking up, the light from your body travels up through the atmosphere and out into space. It travels at the speed of light, away from Earth, past the moon, past Mars, out of the solar system. It will travel forever, carrying the signature of your heat, the fingerprint of your existence, out into the deep cosmos. 1 billion years from now, a photon that left your hand tonight will still be traveling, passing through a distant galaxy, a tiny, silent testament that you were here, that you were warm, that you were alive. You are constantly writing yourself into the universe with light. We are beacons, shining in the dark, exchanging energy with the cosmos in a silent, continuous conversation. The distinction between the observer and the light is blurred. We are the light observing itself. We are the universe's way of seeing its own reflection. And as we drift deeper into the mystery, we must ask, if light is the visible messenger, what about the invisible? What about the darkness? We know that the stars and the gas and the dust, everything that glows, make up only a tiny fraction of the universe. The rest is hidden. The rest is ghost matter. In the next chapter, we are going to turn off the light. We are going to explore the shadows. We are going to look for the invisible ocean that we are swimming in, the mysterious substance that passes through your body by the trillions every second without you feeling a thing. We are going to talk about the dark universe, dark matter, and dark energy, and realize that everything we can see, everything we have talked about so far, is just the foam on top of a deep, dark sea. But for now, stay in the light. Feel the glow of existence. Visualize the photons raining down from the stars, passing through the roof, passing through your closed eyelids, connecting you to the fusion fires of the deep cosmos. You are a creature of the sun, a child of the stars, a temporary knot of frozen light waking up to its own brilliance. Let the speed of light slow down your mind. Let the timelessness of the photon bring you peace. In the realm of light, there is no rushing, no waiting, only the eternal, instant connection of everything to everything else. Sleep now, and let your light shine into the dream. Have you ever stood on the deck of a ship in the middle of the ocean on a moonless night? If you look down, you cannot see the water. All you can see are the white crests of the waves, the foam churning against the hull, glowing faintly in the starlight. If you were a stranger to this planet, you might look at that scene and conclude that the ocean is made entirely of foam. You might think the whitecaps are the only things that exist, floating in a void of nothingness. But you would be wrong. The foam is just the surface decoration, a tiny, fragile byproduct of something far deeper, far darker, and far more powerful. Beneath those white waves lies miles of black water, millions of tons of pressure, vast currents that shape the climate of the entire world, and creatures that have never seen the sun. We are currently making the same mistake when we look at the universe. We look up and see the stars, the galaxies, the glowing nebulae, and we think, this is the universe. But the stars are just the foam. The galaxies are just the whitecaps. Everything we can see, everything we can touch, everything we have discovered in the history of science, protons, electrons, atoms, light, you, me, the earth, the sun, makes up less than 5% of reality. The other 95% is a dark, silent, invisible ocean that we are drifting through right now. Tonight, we are going to turn off the lights of the visible world. We are going to dive beneath the surface of the foam. We are going to explore the dark universe, the twin mysteries of dark matter and dark energy. And we are going to discover that the emptiness of space is not empty at all. It is heavy. It is alive with forces we cannot see. And it is dictating the fate of everything we love. To understand the weight of the invisible, we must go back to a quiet observatory in Arizona in the 1970s. An astronomer named Vera Rubin was doing something that seemed, at the time, rather mundane. She was measuring the rotation speeds of spiral galaxies. A galaxy is like a giant merry-go-round made of stars. Common sense and the laws of Isaac Newton told us how it should spin. On a merry-go-round, The horses near the center move slowly, but they complete a circle quickly because the distance is short. The horses at the edge move fast, but they have a long way to go. But more importantly, in a solar system, the planets work differently. Mercury, close to the sun, zips around at high speed to fight the strong gravity. Pluto, far away, where gravity is weak, moves lazily and slowly. Astronomers expected galaxies to work like the solar system, bright, heavy centers with fast stars, and dark, light edges with slow stars. But when Vera Rubin pointed her spectrograph at the edges of the Andromeda galaxy, and then many others, she saw something impossible. The stars at the edge were not moving slowly. They were moving just as fast as the stars near the center. In fact, they were moving so fast, hundreds of thousands of miles per hour, that they should have been flung out into deep space. The visible gravity of the galaxy, the pull of all the stars and gas we could see, was nowhere near strong enough to hold them in. By all rights, these galaxies should have torn themselves apart billions of years ago. They should be scattered debris, not beautiful spirals. It was as if you spun a pizza dough so fast it should have flown across the room, but instead, it stayed perfectly round and flat. Rubin realized that something was holding the galaxy together, something invisible, something massive. She calculated that to explain the speed of the stars, there had to be 5 or 6 times more mass in the galaxy than what we could see. This missing mass was not just dust, or dim stars, or black holes. It was a ghost substance. It did not emit light. It did not reflect light. It did not block light. It interacted with nothing except gravity. We call this substance dark matter. But the name is just a placeholder for our ignorance. We do not know what it is. We only know what it does. It is the scaffolding of the cosmos. Imagine looking at a city at night from an airplane. You see the strings of streetlights, the clusters of buildings. You don't see the steel girders inside the skyscrapers, but you know they must be there, or the buildings would collapse. Dark matter is the steel of the universe. Every galaxy, including our own Milky Way, is embedded in a vast spherical halo of this invisible stuff. The bright spiral of stars that we call home is just a thin, glowing disk floating in the center of a gigantic dark sphere. This changes how you should visualize your position in space. You are not floating in a vacuum. You are sitting inside a cloud of ghost particles. Right now, as you lie in bed, dark matter is streaming through your body. Millions of particles of it are passing through your skull, your heart, and your sheets every second. They do not touch you. They pass through the atoms of your body as if you were made of mist. To dark matter, you are the ghost. You are the immaterial phantom. It is the dominant stuff of the universe, and we are the rare, exotic exceptions that glow in the dark. For decades, physicists have built deep underground detectors, tanks of liquid xenon buried in gold mines, waiting for a single particle of dark matter to bump into a normal atom. They are listening for a whisper in a hurricane. So far, they have heard nothing. The silence is profound. It suggests that this shadow sector of the universe is complex and rich, perhaps with its own forces, its own particles, maybe even its own dark life that we can never interact with. We are 2 universes occupying the same space, passing through each other like 2 clouds of smoke, linked only by the faint tug of gravity. The gravity of dark matter guided the formation of the first stars. It pulled the gas together after the Big Bang. Without this invisible hand, the universe would have remained a smooth, boring soup. You owe your existence to a substance you will never see. But if dark matter is the glue that holds the universe together, there is another force, even more mysterious, that is trying to tear it apart. This brings us to the second and larger part of the dark ocean, dark energy. If dark matter is the invisible earth beneath our feet, dark energy is the wind that is blowing the sky away. In the late 1990s, two teams of astronomers set out to measure how much the expansion of the universe was slowing down. We knew the universe began with a big bang and had been expanding ever since. But we assumed that the gravity of all the stars and galaxies and all the dark matter would act as a brake. We thought the universe was like a ball thrown into the air. It goes up, but eventually gravity slows it down, and it either stops or falls back. We wanted to know if the universe would eventually stop expanding and crunch back together, or if it would just coast slowly into eternity. The astronomers looked at distant supernovae, exploding stars, to measure this deceleration. What they found shocked them so much that they thought their telescopes were broken. The expansion of the universe was not slowing down. It was not even coasting. It was speeding up. The ball thrown into the air was not falling back. It was strapping on a rocket engine and shooting into space faster and faster. The universe is accelerating. Distant galaxies are rushing away from us at speeds that increase every second. This requires a force, a push, and this push is coming from empty space itself. This is dark energy. Unlike dark matter, which clumps together around galaxies, dark energy is smooth. It is everywhere. It is a property of space itself. And it has a terrifying characteristic. It does not dilute. If you have a box of gas and you expand the box, the gas gets thinner. The density drops. But if you expand a box of space, you get more space, and therefore you get more dark energy. As the universe expands, it creates more dark energy, which pushes the universe apart faster, which creates more dark energy. It is a runaway feedback loop. It is a self-sustaining explosion that is ripping the cosmos apart at the seams. We estimate that dark energy makes up about 68% of the total energy of the universe. Dark matter is about 27%. Normal matter, the stars, the gas, the planets, your body, your dog, the book on your nightstand, is less than 5%. Think about that pie chart. Everything we have ever studied, loved, or known is a rounding error. We are the debris. We are the flotsam floating on a sea of dark forces. What does this mean for the future? It paints a picture of profound isolation. If dark energy continues to accelerate the expansion, eventually the galaxies outside our local group will be pushed away faster than the speed of light. They will cross the cosmic horizon and vanish. The night sky will slowly empty out. In 100 billion years, a civilization living on a planet around a red dwarf star would look up and see nothing. No other galaxies. No evidence of the Big Bang. They would think their galaxy was the entire universe, surrounded by an endless static void. We are living in a privileged time, the only time in cosmic history when we can see the truth of the universe's expansion before the darkness hides it forever. This realization can feel cold. It makes the universe seem hostile, a vast machine indifferent to our presence, rushing toward a lonely, frozen death. But there is another way to look at it. There is a way to find comfort in the dark. In Taoist philosophy, there is a focus on the utility of emptiness. A cup is useful not because of the clay walls, but because of the empty space inside that holds the tea. A room is useful because of the space between the walls. The nothing is what allows the something to function. The dark universe is the container that allows life to exist. Dark matter provided the cradle. Its gravity hugged the primordial gas clouds and nursed them until they ignited into stars. Without that dark embrace, the gas would have remained too thin to form anything. There would be no suns to warm us. And dark energy. Dark energy might be the reason the universe didn't collapse back on itself instantly. It is the breath of the cosmos exhaling, creating room for things to happen. We exist in the balance between the pull of the dark earth and the push of the dark wind. We are the delicate structure tensioned between these two titans. And consider the mystery of the vacuum. In quantum physics, there is no such thing as truly empty space. The void is seething with potential. Virtual particles pop in and out of existence. Fields vibrate. Dark energy suggests that space itself has weight, that nothingness is actually a physical object with its own energy. When you look at the empty corners of your room, you're not looking at an absence. You're looking at a presence. You are looking at a substance that is more powerful than the walls of your house. The air you breathe is thin, but the space it occupies is thick with the latent power of the cosmos. There is a humility in this. For thousands of years, humans placed themselves at the center of everything. We thought the earth was the center, then the sun, then our galaxy. Now, science has humbled us one last time. We are not even made of the main stuff of the universe. We are the rare spice sprinkled on top of the dark dish. But rarity implies value. If normal matter, the stuff of consciousness, of light, of love, is only 5% of reality, then it is precious. We are the diamond dust in the coal mine. We are the only part of the universe that can reflect light. We are the only part that can wake up. The dark ocean is vast and blind. We are the eyes. As you lie there, try to sense this invisible ocean. Imagine gravity, not just as a downward pull, but as the grip of the dark matter halo that surrounds our galaxy, holding us safe in the velvet night. Imagine the space between your eyes and the ceiling not as empty air, but as a field of dark energy, gently pushing, expanding, participating in the great breath of the universe. You are swimming in the unknown, and the unknown is not something to fear. It is the medium of your existence. We have explored the very large, the galaxies, the black holes, the expanding web of the dark universe. We have looked outward until our minds reeled from the scale. But the mystery of the cosmos is not just in the size, it is in the substance. If we turn our gaze away from the telescope and look into the microscope, we find that the confusion does not go away. It gets stranger. We have said that matter is made of atoms, and atoms are made of particles. But what are particles? Are they little billiard balls? Are they points of energy? In the next chapter, we are going to dissolve the solid world completely. We are going to explore the idea that the universe is not made of things, but of music. We are going to listen to the music of the spheres in a literal sense. We will dive into string theory, the idea that every electron and quark in your body is actually a tiny, vibrating loop of energy, playing a specific note on a cosmic cello. We will ask if the universe is ultimately a symphony, and if you are a song being sung by the vacuum itself. But for tonight, be content with the darkness. Be content to be the foam on the deep ocean. The foam is beautiful. The foam catches the starlight. The foam feels the wind. The dark universe does the heavy lifting, holding the structure together, expanding the stage, so that you, the light, the consciousness, the rare and beautiful 5%, can have a place to dream. Rest now in the arms of the invisible. The mystery is holding you. Have you ever closed your eyes at a concert, or while wearing headphones in a dark room and felt the music dissolve the boundaries of your body? There is a moment when the vibration of the cello or the deep thrum of the bass ceases to be a sound you hear and becomes a physical force you feel in your chest. In that moment, the distinction between the listener and the song blurs. You vibrate in sympathy with the melody. You become the music. We often dismiss this as a fleeting emotional experience, a trick of the brain's pleasure centers. But what if this sensation is actually a moment of profound scientific clarity? What if, in those moments of sonic immersion, you're feeling the deepest truth of the universe? For thousands of years, mystics and poets have claimed that the world is made of sound, that creation is a song sung by the divine. And for thousands of years, scientists dismissed this as a pretty metaphor. But today, at the bleeding edge of theoretical physics, the math is telling us something extraordinary. If we zoom in past the cells, past the molecules, past the atoms, and even past the subatomic particles we learned about in school, we find that there are no solid objects down there. There are no tiny billiard balls. There is only vibration. Tonight, we are going to tune our minds to the frequency of the cosmos. We are going to explore string theory, the idea that the universe is a vast symphony of vibrating strands of energy. And we are going to discover that you are not just a collection of atoms. You are a chord being played on the instrument of space-time. To understand why physicists had to invent strings, we have to look at the broken pieces of our current understanding. For the last century, physics has been a house divided. On one side, we have general relativity, Einstein's masterpiece. It describes the world of the large, stars, galaxies, gravity, the curvature of space. It is a theory of smooth, rolling landscapes. On the other side, we have quantum mechanics. It describes the world of the small, atoms, photons, quarks. It is a theory of jittery, pixelated chaos. Both theories work perfectly in their own domains. We use relativity to navigate spacecraft to Pluto, and we use quantum mechanics to build the microchips in your phone. But there is a problem. A deep, ugly crack runs through the foundation of physics. When we try to combine these two theories, when we try to describe something that is both very heavy and very small, like the center of a black hole or the moment of the Big Bang, the math explodes. The smooth curves of gravity crash into the jagged jitters of the quantum world, and the equations spit out nonsense answers like infinity. This conflict tells us that we are missing something fundamental. We are like explorers looking at a map where the continent of gravity and the continent of quantum are separated by an uncrossable ocean. We need a bridge. We need a unified theory, a theory of everything that can describe the entire universe in a single, elegant equation. And the best candidate we have for this bridge is string theory. The central idea of string theory is elegantly simple, yet it shatters our intuition about matter. Standard physics treats particles like electrons or quarks as point particles. This means they are infinitely small dots with no size, no shape, and no internal structure. They are just coordinates in space that have properties like mass and charge. But string theory asks, what if they are not dots? What if, instead of a zero-dimensional point, the fundamental unit of reality is a one-dimensional line, a filament, a string? Imagine a guitar string. If you pluck it, it vibrates. Depending on how much tension is in the string and where you put your finger, it vibrates at a different frequency. A fast vibration produces a high note. A slow vibration produces a low note. You can play an A, a C, or an F sharp on the same string just by changing the way it wiggles. String theory says that the particles of the universe are just like the notes on a guitar. An electron is not a different thing from a quark. They are the exact same type of string, just vibrating at a different frequency. One pattern of vibration makes the string look and act like an electron. Another pattern makes it look like a photon. Another makes it look like a neutrino. This means that the rich diversity of the universe, the gold in the ground, the oxygen in the air, the light from the sun, the gravity holding you down, is all generated by a single fundamental object playing different songs. The universe is not a Lego set made of different types of bricks. It is a choir. It is a cosmic orchestra where every particle is a musician playing a solo, and together they create the symphony of reality. This metaphor of music is not just poetic license. It is the literal mathematical description of nature. The mass of a particle corresponds to the pitch of the note. The heavier the particle, the higher the energy of the vibration. But these strings are incredibly small. To see one, you would have to zoom in on an atom until it was the size of the observable universe. And even then, the string would be no larger than a tree. They exist at the Planck length, the smallest possible distance in physics, around 10 to the power of negative 35 meters. At this scale, the concept of smooth space breaks down completely. The strings are under immense tension, wriggling and snapping with the energy of the cosmos. And here is where the theory performs its greatest magic trick. When physicists worked out the math of these vibrating strings, they found that one specific vibration mode corresponded to a particle with 0 mass and 2 units of spin. They recognized this particle immediately. It was the graviton, the hypothetical carrier of the force of gravity. In standard quantum mechanics, gravity is impossible to include. But in string theory, gravity pops out of the equations automatically. You don't have to force it in. The theory demands that gravity exists. This was a revelation. It suggested that gravity is just another note in the song. It healed the rift between Einstein and the quantum world. If the universe is made of strings, then gravity and atoms are part of the same sheet music. But this elegance comes with a price, a strange, mind-bending price. When the theorists tried to make the math work, they found that the strings needed room to vibrate. In our familiar world, we have 3 dimensions of space: up, down, left, right, and forward, backward. We also have 1 dimension of time. That makes 4 dimensions. But the strings were too complex. They couldn't vibrate in the right patterns to create the particles we see if they were stuck in just 3 dimensions of space. They would bump into the walls of reality. The math only worked. The equations only balanced. If the universe had more dimensions, many more. Superstring theory predicts that the universe has 10 dimensions, 9 dimensions of space and 1 dimension of time. M theory, an even more advanced version, suggests there are 11. This sounds insane. If there are 6 extra dimensions of space right here in this room, where are they? Why can't we see them? Why can't we move through them? The answer, according to the theory, is that these extra dimensions are compactified. They are curled up into tiny, microscopic shapes that are too small for us to perceive. Imagine you are looking at a garden hose lying across a lawn from far away. It looks like a one-dimensional line. You can only walk forward or backward along it. But if you are an ant crawling on the hose, you realize that there is a second dimension. You can walk around the circumference of the hose. The circular dimension is real, but it is small and curled up. String theory suggests that every point in our three-dimensional space is actually a tiny knot of 6 extra dimensions curled up into a complex shape called a Calabi-Yau manifold. These shapes are incredibly intricate, twisted like geometric origami. Here is the beautiful part. The shape of these extra dimensions determines the sound of the strings. Just as the shape of a French horn produces a different sound than the shape of a flute, the geometry of the curled-up dimensions determines how the strings can vibrate. If the Calabi-Yau shape has a hole here or a twist there, it forces the string to vibrate in a specific way, creating a specific particle with a specific mass. This suggests that the fundamental constants of nature, the strength of gravity, the mass of the electron, the speed of light, are not random numbers. They are determined by the geometry of the hidden dimensions. The universe is the way it is because of the shape of the invisible space we cannot see. This leads to a profound realization about what you are. If string theory is correct, your body is a collection of trillions upon trillions of tiny strings, all vibrating in a specific harmony. You are a localized standing wave in the ocean of space-time. The stability of your atoms, the chemistry of your cells, the electrical signals of your thoughts, all of it is sustained by the continuous, rhythmic vibration of energy. You're not static. You are a process. You are a song that the universe is singing in this particular location for a brief moment in time. When you die, the strings do not disappear. They just stop playing the chord that is you and begin playing the chords of the soil, the air, and the grass. The energy remains, but the melody changes. There is a concept in ancient Greek philosophy called musica universalis, or the music of the spheres. Pythagoras believed that the movement of the planets and stars created a divine harmony, a celestial music that we could not hear because it was always present. String theory is the modern, mathematical realization of that ancient dream. It tells us that the universe is indeed a musical instrument. The deep, dark vacuum of space is not silent. It is humming with the potential of all possible particles. Every electron is a plucked string. Every graviton is a strummed chord. The physics of the universe is the harmony of the strings. The chemistry of life is the melody of the strings. This perspective shifts how we relate to the cosmos. We often feel small and disconnected, alienated by the cold vastness of space. But if the universe is music, then we are not separate from it. You cannot separate a wave from the ocean. You cannot separate a note from the air. We are the universe vibrating. We are the resonance of the Big Bang, echoing forward through time. The same fundamental vibration that creates the heart of a star creates the carbon in your DNA. There is a deep physical unity in this view that transcends the isolation of the ego. But string theory opens the door to something even stranger than extra dimensions. It opens the door to the multiverse. We mentioned earlier that the shape of the extra dimensions determines the laws of physics. But there are millions of possible shapes for these Calabi-Yau manifolds. In fact, there are estimated to be 10 to the power of 500 possible shapes. That is a 1 followed by 500 zeros, a number so large that there are not enough atoms in the universe to write it down. Each of these shapes corresponds to a different possible universe, with different particles, different forces, and different laws of physics. This is the cosmic landscape of string theory. It suggests that our universe is just one valley in a vast, infinite landscape of possibilities. In one valley, the strings vibrate to create a universe with no gravity. In another, they create a universe with 12 forces instead of 4. In another, electrons are as heavy as bowling balls. Most of these universes would be uninhabitable, chaotic, and dead. But because there are so many possibilities, and because the mechanism of cosmic inflation, the rapid expansion of space, can create new bubble universes endlessly, it is statistically inevitable that a universe like ours would eventually be played. This brings us back to the anthropic principle we discussed earlier, but with a musical twist. We are living in this universe where the instrument is tuned perfectly for life. We are the result of a specific, rare, and beautiful harmony. Out in the vast landscape of the multiverse, there may be other symphonies playing, other realities vibrating with exotic forms of matter and energy that we can never imagine. But here, in our bubble, the music has swelled to a crescendo that allows for consciousness. The strings have organized themselves into complexity. They have knotted themselves into stars, planets, and people. So, tonight, as you listen to the silence of the room, try to listen deeper. Try to imagine that the silence is an illusion. Beneath the quiet, the air is vibrating. The walls are vibrating. Your own body is vibrating. You are a symphony of strings, playing the song of existence. The anxiety you feel, the stress of the day, is just a dissonance in the music, a temporary clash of notes. But the underlying structure, the fundamental vibration of your being, is pure energy. It is the same energy that powers the sun. It is the same energy that holds the galaxies together. You are in tune with the cosmos, whether you feel it or not. Music has the power to heal because it reminds us of this fundamental truth. When we listen to a beautiful piece of music, we are hearing a reflection of the deep structure of reality. We are hearing math turned into emotion. We are hearing the code of the universe translated into a language our hearts can understand. That is why music feels like home. It is a return to the source. It is a reminder that we are not solid, separate lumps of matter, but flowing, rhythmic patterns of energy. The string theorists are still working on the equations. They are still looking for the master equation that will explain exactly why the extra dimensions are curled up the way they are. They have not finished the score yet, but the glimpse they have given us is enough to change our lives. It tells us that reality is richer, deeper, and more harmonious than we ever dared to dream. It tells us that the solid world is a veil, and behind the veil is a dancing, vibrating, singing energy that connects everything to everything. But if we are music and the universe is the instrument, who is the player? Or is the universe playing itself? This question leads us to the edge of science and into the realm of philosophy. But there is one more scientific frontier we must cross, one more mystery that connects the very beginning of time to the very end. We have talked about the structure of matter, the nature of time, and the invisible forces. But we haven't talked about the engine that drives it all. We haven't talked about the heat. In the next chapter, we are going to look at the fire. We are going to explore the concept of heat death and the ultimate fate of the universe. But we are going to find a surprise hidden in the ashes. We are going to discover that in a universe destined to freeze, life is a rebellion. We are going to see that you are a heat engine, a little pocket of order, fighting a heroic war against the chaos of the cosmos. We will learn why life is rare, why it is precious, and why your warmth is the most defiant thing in the universe. So, let the strings of your mind relax, loosen the tension. Let your thoughts vibrate at a lower, slower frequency. Drift down into the harmony of sleep. You are a song that the universe loves to sing. You are a perfect chord in the great symphony. Let the music carry you away. Have you ever sat in front of a dying campfire on a cold autumn night, watching the last few embers pulse with a faint orange glow while the darkness of the forest creeps in closer and closer? There is a profound instinctual sadness in watching a fire go out. It feels like the end of a story. It feels like a surrender. We huddle closer to the warmth, feeding the flames with twigs and leaves, trying to keep the light alive for just a few minutes longer, because deep down in our ancient primate brains, we know that the cold is the natural state of things. We know that warmth is a temporary miracle, and we are right. If you were to take a thermometer out into the deepest voids of intergalactic space, far away from any star or galaxy, the mercury would drop until it hit a temperature that is almost impossible to comprehend, 2.7 degrees above absolute zero. That is minus 455 degrees Fahrenheit. The universe, in its vast majority, is a freezer. It is a cold, dark, empty wasteland where nothing moves and nothing changes. And yet, here you are, lying in your bed. Your body is a furnace, maintaining a constant temperature of roughly 98.6 degrees. You are a blazing torch of heat in a cosmos that wants to freeze you solid. Tonight, we are going to explore the thermodynamics of your existence. We are going to look at the ultimate fate of the universe, the heat death. And we are going to discover that life is not just a biological accident. Life is a rebellion. You are a soldier in a thermodynamic war, fighting a heroic battle against the inevitable decay of the universe. And your weapon is the very warmth that lets you sleep. To understand this war, we must return to the law we touched upon earlier, the second law of thermodynamics. This is the law that says entropy, disorder, always increases. It says that energy tends to spread out. Heat flows from hot things to cold things, never the other way around. A hot cup of coffee left on a table will always cool down until it matches the room. The room will never spontaneously heat the coffee up. The universe is constantly trying to reach equilibrium. It wants to be the same temperature everywhere. It wants to smooth out the differences. It wants to stop the flow. This state of perfect balance, where all energy is evenly distributed and nothing interesting ever happens again, is called the heat death. It is the destiny of the cosmos. Every star that burns is slowly emptying its fuel tank. Every galaxy that shines is spending its capital. We are moving inexorably toward a future of infinite, cold silence. But wait, look at yourself. Look at a flower. Look at a city. Look at the intricate, organized complexity of a single strand of DNA. If the universe is supposed to be getting messier and colder, how is it possible that life exists? Life is highly ordered. Life is complex. Life concentrates energy rather than spreading it out. A living cell is a masterpiece of organization, a fortress of structure in a chaotic world. Does life violate the second law of thermodynamics? Is biology a miracle that breaks the rules of physics? In the mid-20th century, a physicist named Erwin Schrödinger, the same man with the famous cat, wrote a book called What is Life? In it, he proposed a brilliant solution. He said that life does not break the law, it exploits it. Life is what physicists call a dissipative structure. We maintain our high internal order by constantly importing order from the outside and exporting disorder to the outside. We eat food, which is high-quality chemical energy, and we release body heat and waste, which is low-quality, disordered energy. We are essentially sucking the order out of the environment and dumping our entropy back into the universe. We are paying for our complexity by speeding up the decay of the rest of the cosmos. Think about what this means. Every breath you take, every beat of your heart, every thought that flickers through your mind requires energy. To maintain the intricate structure of your brain and body, you are burning fuel. And that fuel comes ultimately from the sun. The sun is a localized knot of low entropy, a reservoir of order. By eating plants, or animals that ate plants, you are tapping into that solar stream. You are keeping your own internal flame alive by consuming the order of the star. But in doing so, you are releasing heat. You are radiating infrared light into your room, which heats the air, which eventually radiates out into space. You are a heat engine. You are actively contributing to the heat death of the universe. But you are creating a temporary pocket of beauty and consciousness while you do it. This changes the definition of what you are. You are not a thing. You are a flow. You are like a whirlpool in a river. The water in the whirlpool is constantly changing, flowing in and flowing out, but the shape of the whirlpool remains stable. You are a pattern of energy flow. If the flow stops, if you stop eating, breathing, or staying warm, the structure collapses. The second law takes over, and you dissolve back into the equilibrium of dust and ashes. Being alive is an active, dynamic act of defiance. It is the act of holding a shape against the current of chaos. But let us zoom out. If life is a fire feeding on the stars, what happens when the stars go out? The timeline of the future is a sobering lesson in humility. We are currently living in what cosmologists call the stelliferous era, the era of stars. This is the golden age of the universe. It is the time when galaxies are bright with fusion, when planets are warm, and when life is possible. But this era is brief. It is a flash in the pan. The most massive stars burn out in just a few million years. Stars like our sun last for about 10 billion years. The smallest stars, the red dwarfs, sip their fuel so slowly that they can burn for trillions of years. But eventually, even the red dwarfs will die. Imagine a time, 100 trillion years from now. The last star in the universe has just flickered out. The galaxies have gone dark. The great engines of fusion have fallen silent. The universe will be a graveyard of stellar remnants, white dwarfs, neutron stars, and black holes. This is the beginning of the degenerate era. In this era, the only light will come from the faint glow of cooling embers. Planets will freeze. Any life that wants to survive will have to huddle around the decaying corpses of dead stars, scavenging the last scraps of heat. But even this will not last forever. Over immense timescales, numbers so large that if you wrote them out, the zeros would fill the entire sky. The stellar remnants will decay. The white dwarfs will cool until they become black dwarfs, balls of carbon as cold as space itself. The neutron stars will slow their spins, and then the black holes will take over. This is the black hole era. The universe will be dominated by these gravity monsters. But as we learned in the previous chapter, even black holes are mortal. They will slowly evaporate via Hawking radiation. One by one, in flashes of gamma rays, the black holes will disappear. This vision of the future, the big freeze, is widely considered to be the most likely end of our world. It sounds terrifying. It sounds like a tragedy. It renders all human achievement, all art, all science, all love, ultimately temporary. If everything ends in ice and silence, what was the point? Why did the universe bother to wake up at all? But there is a different way to interpret this story, a way that turns the tragedy into a triumph. Think about the concept of scarcity. Gold is valuable because it is rare. Diamonds are precious because they are hard to find. If the universe were full of life and warmth forever, if stars burned for eternity, then existence would be cheap. It would be commonplace. But the fact that the stelliferous era is finite, the fact that warmth is a temporary exception to the rule, makes this moment, right now, infinitely precious. We are living in the Goldilocks moment of cosmic history. We are here at the party before the lights go out. The universe has spent 13.8 billion years preparing the stage for us. It forged the carbon, it gathered the gas, it ignited the sun, it evolved the mind. It has given us a window of time, a brief, glorious summer, to look around, to understand, and to feel. The fact that it will end does not make it meaningless. It makes it urgent. It makes the warmth of your bed, the sound of your breath, and the love you feel for others the most important things in existence. And consider the nature of heat-death again. It is a return to equilibrium. It is a return to peace. The universe began in a violent explosion of energy, and it has been struggling to calm down ever since. The expansion, the cooling, the entropy, it is all a process of relaxation. The cosmos is slowly exhaling. It is settling into a long, eternal sleep. In a way, the heat death is the ultimate rest. It is the stillness after the song. But here is a wilder thought, one that keeps the spark of hope alive even in the dark era. Some physicists, like Roger Penrose, have suggested that the end might actually be a beginning. In a universe that contains only radiation, scale loses its meaning. Without mass, there is no way to tell the difference between a universe that is infinitely huge and a universe that is infinitely small. The geometry of the remote future looks suspiciously like the geometry of the Big Bang. Penrose proposes a theory called conformal cyclic cosmology, which suggests that the heat death of one aeon becomes the Big Bang of the next. The universe might be a phoenix. It might burn itself out, dissolve into light, and then, through a trick of mathematical geometry, be reborn as a new singularity, ready to expand again. If this is true, then the fire never truly goes out. It just resets. The rebellion of life is not a doomed last stand. It is a recurring verse in an infinite song. We are the flame that burns in every cycle. We are the witnesses that return again and again to warm the void. So, bring your awareness back to the warmth of your own body. Feel the heat radiating from your skin. That heat is a victory. It is a statement of existence. You are a lighthouse of entropy, consuming the order of the past to illuminate the present. You are doing exactly what the universe needs you to do. You are helping the cosmos express its energy. You are the fire in the dark forest, and do not fear the cold that lies outside. The cold is just the canvas. The warmth is the painting. The contrast is what makes it beautiful. As you drift towards sleep, imagine yourself as a glowing ember in the hearth of the galaxy. You are safe. You are warm. You are part of the golden age. The universe is holding you in its brief, bright embrace, protecting you from the chill of the void. But there is one more layer to this mystery. We have talked about the physical universe, the matter, the time, the forces, the heat. But we have avoided the most puzzling question of all. Why is there a universe at all? Why is there something rather than nothing? And is the universe actually a physical object, or is it something else entirely? Is it possible that the universe is not made of atoms, or strings, or fields, but of mathematics? In the next chapter, we are going to strip away the physical world completely. We are going to look at the code behind the curtain. We are going to explore the idea that reality is a mathematical structure, a giant equation thinking itself into existence. We will ask if the number pi is more real than the planet Earth, and if you are, at your core, a complex algorithm running on the hardware of nothingness. For now, cherish the fire. Cherish the simple, biological miracle of being warm. You are a rare and beautiful thing, a machine that turns starlight into dreams. The universe may be destined for silence, but right now it is singing through you. Rest in the warmth. The fire will last for tonight. Have you ever looked at the center of a sunflower? If you stare at it closely, you will see a series of spirals, curving left and curving right, packing the seeds into the most efficient pattern possible. If you were to count those spirals, you would find numbers that belong to a specific sequence, the Fibonacci sequence. Now, imagine you are looking at a hurricane from space. The great white arms of the storm curl in the exact same mathematical ratio. Now, look even further at a spiral galaxy spinning in the deep void. The shape is the same. From the flower in your garden to the storm in the atmosphere to the monster in the cosmos, the same invisible rule is shaping reality. It is a ghostly fingerprint that appears everywhere we look. We tend to think of mathematics as a tool we invented, a set of scratches on a chalkboard used to count sheep or calculate taxes. But the deeper we look into the universe, the more it begins to look like mathematics is not something we invented. It is something we discovered. It is the bedrock. In fact, some physicists are now asking a question that sounds like madness. Is the physical world even real? Or is the universe actually a giant, complex mathematical structure, and we are just self-aware variables wandering through the equation? Tonight, we are going to strip away the illusion of matter completely. We are going to enter the realm of pure logic. We are going to explore the idea that the universe is not made of atoms, strings, or energy, but of numbers. And we are going to find a strange kind of peace in the perfection of the code. To understand why this idea is so compelling, we have to go back to the ancient Greeks. Plato believed that the world we see with our eyes, the world of rocks, trees, and chairs, was just a shadow. He believed that the real world was a world of perfect forms accessible only to the intellect. In his view, a circle drawn in the sand is imperfect. It is bumpy. It is temporary. It will wash away. But the idea of a circle, the mathematical definition of a set of points equidistant from a center, is perfect, eternal, and indestructible. It exists whether anyone draws it or not. For centuries, scientists thought this was just philosophy. But when Galileo pointed his telescope at the sky and began to measure the motion of the planets, he wrote something that changed history. The book of nature is written in the language of mathematics. Galileo realized that the universe does not just happen to follow mathematical rules. It follows them with a precision that is eerie. When Newton wrote down the law of gravity, he found that he could predict the position of a planet years in advance using a simple equation. Why should the universe care about our equations? Why should a planet, a massive ball of rock and gas, follow a rule written by a human on a piece of paper? The physicist Eugene Wigner called this the unreasonable effectiveness of mathematics. It is a mystery that lies at the heart of science. If math were just a human invention, a cultural language like English or French, it should be messy. It should work sometimes and fail others. But it doesn't. The math we invent in a windowless room often turns out to describe phenomena in the universe that we haven't even discovered yet. Consider the story of antimatter. In 1928, the physicist Paul Dirac was playing with the equations for the electron. He realized that his equation had two solutions. Just as the square root of 4 can be 2 or minus 2, his equation allowed for an electron with positive energy and an electron with negative energy. At the time, no one had ever seen a positive electron. It seemed like a mathematical glitch. But Dirac trusted the math. He predicted that this anti-electron must exist. 4 years later, it was found in a cosmic ray detector. The math knew the universe better than the physicists did. The code was there before the observation. This happens again and again. Black holes, radio waves, the Higgs boson, all were predicted by mathematics long before they were seen by eyes. It suggests that the math is the territory and the physical world is just the map. But let us take a leap. Let us go to the extreme. The cosmologist Max Tegmark has proposed something called the mathematical universe hypothesis. He suggests that the universe doesn't just have some mathematical properties. It is mathematics. Think about a video game. When you play a game, you see a character running through a forest. You see trees, light, shadows, monsters. It looks solid. It feels real. But if you were to look under the hood of the game, you would find no trees. You would find no light. You would find only code. You would find sequences of zeros and ones, complex algorithms processing data. The reality of the game is entirely mathematical. The visual experience is just the user interface. Tegmark argues that our universe is exactly the same. We look around and see atoms, light, and stars. We feel solidity, but that is just our interface. It is the way our brains, which are also part of the simulation, interpret the data. At the fundamental level, an electron is not a little gray ball. It is a set of numbers. It has a mass number, a charge number, a spin number. If you take away the numbers, there is nothing left. The particle is just a bundle of mathematical properties. In this view, the theory of everything we are searching for is not a description of the universe. It is the universe. We are living inside a giant, complex, self-consistent structure that is purely abstract. This is a dizzying thought. It makes you feel transparent, like a ghost made of geometry, but there is a beauty in it. Think about the number pi, 3.14159, and so on forever. The digits of pi never repeat and never end. They are infinite. But pi is not just a random list of numbers. It is a necessary consequence of the logic of geometry. It exists outside of time. Pi was the same value before the Big Bang, and it will be the same value after the heat death. It cannot be created, and it cannot be destroyed. If the universe is a mathematical structure, then you share in that immortality. The equation that describes you, the complex pattern of information that defines your consciousness, is a permanent part of the mathematical landscape. You are a theorem in the mind of the cosmos. To visualize this landscape, think of the Mandelbrot set. You have probably seen it, that famous beetle-shaped fractal that looks like a psychedelic painting. It is generated by an incredibly simple equation. Z equals Z squared plus C. That's it. A high school student could solve it. But when you feed the numbers back into the equation, iterating it over and over, something miraculous happens. A shape emerges of infinite complexity. If you zoom in on the edge of the Mandelbrot set, you see spirals. If you zoom in on the spirals, you see seahorses. If you zoom in on the seahorses, you see miniature versions of the original shape. You can zoom in forever, literally forever, and you will never run out of new, beautiful, intricate patterns. You will never see the same scene twice, yet it is all generated by one tiny line of code. This is the power of emergence. Simple rules can create infinite complexity. The universe might be a fractal. The laws of physics might be the simple equation, Z squared plus C, And the galaxies, the stars, the planets, the biology, and your own life are the beautiful, swirling patterns that emerge when you run that equation for 13 billion years. We are the seahorses on the edge of the cosmic Mandelbrot set. We are complexity born from simplicity. And just like the fractal, we are self-similar. The atom looks like a solar system. The brain looks like the cosmic web. The spiral of the galaxy looks like the spiral of the shell. The code repeats itself on every scale, singing the same song in different octaves. This idea that we are code leads us to the concept of the simulation hypothesis. If the universe is mathematical, could it be running on a computer? It is a favorite topic of science fiction, and tech billionaires love to talk about it. They argue that if civilizations continue to advance, they will eventually build computers powerful enough to simulate entire universes. And if they run millions of simulations, then the odds that we are in the one real universe are tiny. We are almost certainly in a simulation, but I think this misses the point. It implies that there is a real physical computer somewhere made of real atoms running our world. But what is that computer made of? And what is the universe that it sits in made of? Eventually you have to hit bottom. Eventually you have to find a reality that doesn't depend on anything else. Tegmark's idea is simpler. You don't need a computer. The math doesn't need to be calculated to exist. The number 4 doesn't need a computer to make it 4. It just is. The mathematical structure of the universe exists in the realm of possibility, timeless and eternal. We experience it as happening because we are traversing the structure like an ant crawling along a statue. The statue is still. The ant feels motion. The math is static. Our consciousness feels time. This removes the need for a programmer. It removes the need for a God in the traditional sense. Or rather, it redefines God. If God is that which is eternal, omnipresent, and the source of all order, then mathematics fits the description perfectly. The laws of physics are the commandments. The structure of space-time is the temple. And we are the prayers, the intricate, self-aware thoughts of the system. There is a profound peace to be found in the world of numbers. The physical world is messy. It is full of decay, pain, and uncertainty. Bodies age, buildings crumble, relationships end. But the mathematical world is clean. It is pure. It is a sanctuary of absolute truth. In a right triangle, the square of the hypotenuse is always equal to the sum of the squares of the other two sides. It was true for the Babylonians. It is true for us. And it will be true for the aliens in the Andromeda Galaxy. It is a truth that cannot be corrupted. When you are feeling overwhelmed by the chaos of life, retreating into logic is like entering a quiet, white room. It is a place of rest. This is why we find geometry so soothing. The symmetry of a snowflake, the arch of a bridge, the circle of the moon. Our brains are hardwired to recognize and enjoy mathematical patterns. We find beauty in order. When you listen to music, as we discussed in the last chapter, you are enjoying the mathematics of frequency. A major chord sounds happy because the ratios of the frequencies are simple, 4 to 5 to 6. A dissonant chord sounds sad or scary because the ratios are complex and clashing. You are doing calculus with your ears. You are feeling the math emotionally. So, as you lie there, try to strip away the sensory details of your room. Forget the color of the walls, the texture of the sheets, the temperature of the air. Visualize the geometry. See the room as a set of lines and angles. See your body as a collection of cylinders and spheres. See the gravity holding you down as a vector arrow pointing to the center of the earth. See the air molecules bouncing off the walls as a probability distribution. You are floating in a matrix of information. The world is not stuff. It is data. And you are a data processor. But you are a very special kind of processor. You are not just a passive calculator. You are a processor that feels. You are an equation that knows it is an equation. This is the hard problem of consciousness that we touched on earlier, but now seen through the lens of math. How does a set of numbers feel pain? How does an algorithm fall in love? This is the mystery that suggests that math, while it describes the structure, might not capture the essence. There is a fire in the equations, as Stephen Hawking put it. What breathes fire into the equations and makes a universe for them to describe? Perhaps the math is just the skeleton and consciousness is the flesh. Or perhaps consciousness is a fundamental property of the numbers themselves, a kind of inner view of the information. If this is true, then everything is conscious. An electron has a tiny, primitive spark of experience. A rock has a slow, heavy consciousness. And you, with your complex brain, are a blinding spotlight of awareness. Let the cold, clean wind of the mathematical universe blow through your mind. Let it sweep away the clutter of your daily worries. Your problems are small variables in a vast equation that balances perfectly. You are part of a symmetry that spans the cosmos. You are supported by the logic of existence. You cannot fall out of the universe because you are defined by the universe. You are a necessary integer in the sum of reality. We have now dismantled the physical world. We have turned matter into energy, energy into strings, and strings into numbers. We have reached the bedrock of abstraction. But we are still alone. In all this vast mathematical cathedral, we have only talked about our consciousness, our physics, our existence. But if the laws of math are universal, if they apply everywhere in the infinite expanse of the cosmos, then surely, the equation has produced other solutions. Surely, we are not the only thinkers in the void. In the next chapter, we are going to look outward again. We are going to turn our radio telescopes to the stars and listen for a signal. We are going to confront the Fermi paradox, the great silence. We are going to ask, where is everybody? Are we the first? Are we the last? Or are we simply being ignored? We will explore the possibility that the galaxy is teeming with civilizations that are too advanced or too different for us to perceive. We will look for the ghost in the machine of the Milky Way. But for tonight, be a number, be a perfect, singular one, or be a zero, a point of pure potential, empty and open. Rest in the certainty of the code. The universe is calculated to the last decimal point, and you are exactly where you need to be. The equation is balanced. The solution is sleep. Have you ever walked out into the middle of a desert or the center of a frozen lake and shouted as loud as you could just to hear the sound die? There is a specific kind of loneliness that comes from shouting into a void and hearing no echo. It is the feeling of being small, the feeling of being singular, the feeling that your voice does not matter to the landscape. We have been shouting into the canyon of the universe for nearly a century now. We have built ears of aluminum and steel, giant radio telescopes, dish-shaped like cups, and turned them towards the stars, listening for a whisper, a beep, a pattern, anything that would tell us we are not the only ones awake. We have sent our own signals, bursts of radio waves, carrying the prime numbers and the sound of laughter, traveling at the speed of light into the deep dark. And the response has been a silence so profound, so heavy, and so absolute that it has become the single most disturbing fact in all of science. Tonight, We are going to confront the Fermi paradox. We are going to look at the numbers that say the galaxy should be teeming with life, and we are going to look at the empty sky that says it is not. We are going to ask the question that haunts every astronomer. Are we the first? Are we the last? Or are we simply the only ones who don't know the rules of the game? To understand the weight of this silence, we must first understand the scale of the stage. The Milky Way galaxy, our home city of stars, is a flat, spiral disk that measures 100,000 light-years across. It contains roughly 400 billion stars. That is 400 billion suns, many of them older than our own. For a long time, we didn't know if these stars had planets. We thought our solar system might be a freak accident. But in the last 2 decades, the Kepler Space Telescope has taught us something wonderful and terrifying. It taught us that planets are as common as dirt. Almost every star in the night sky has at least one planet. Billions of them are Earth-sized. Billions of them orbit in the habitable zone, the Goldilocks region, where water can be liquid. If you run the numbers conservatively, there could be as many as 40 billion Earth-like planets in the Milky Way alone. 40 billion stages for life to act upon. Now, add the element of time. The universe is 13.8 billion years old. The Earth is only 4.5 billion years old. This means there were stars and planets that formed, lived, and died billions of years before our sun was even born. If life is a natural chemical process, if it happens automatically wherever you have water, energy, and time, then it should have started on those ancient worlds long ago. Imagine a civilization that started just 1 million years before us. 1 million years is a blink of an eye in cosmic time. But think about what humans have done in just 10,000 years of civilization. We went from stone tools to space stations. A civilization 1 million years ahead of us would be indistinguishable from God's. They would not just be building cities. They would be engineering stars. They would be mining black holes. They would have spread across the entire galaxy. This is the heart of the paradox. Even with slow propulsion, just poking along at a fraction of the speed of light, a civilization could colonize the entire Milky Way in a few million years. It is a mathematical inevitability. They should be everywhere. We should see their Dyson spheres blocking the light of stars. We should hear their communication networks buzzing in the radio spectrum. We should see their robotic probes visiting our solar system. The physicist Enrico Fermi realized this in 1950. He was sitting at lunch talking about space travel when he suddenly asked, "Where is everybody?" The question hangs over us like a sword. There are only a few possible answers, and each one forces us to reconsider our place in the universe. The first possibility is the rare earth hypothesis. Maybe we are wrong about how easy it is to make life. Maybe having water and rock is not enough. Maybe you need a large moon to stabilize the axis. Maybe you need a magnetic field to block the radiation. Maybe you need a Jupiter to suck up the asteroids. Maybe the spark of life, the transition from dead chemistry to a self-replicating cell, is so fantastically unlikely that it has only happened once. If this is true, then the silence is the silence of a graveyard. We are the only living things in a universe of dead stone. We are a miracle, but we are also an orphan. It means that the entire burden of consciousness, the only eyes that can see the universe, belongs to us. If we destroy ourselves, the universe goes blind. The second possibility is the great filter. This theory suggests that there is some hurdle, some challenge in the development of life that is almost impossible to cross. There is a wall that stops civilizations from becoming galactic. The question is, where is the wall? Is it behind us, or is it ahead of us? If the filter is behind us, if the hard part was getting multicellular life or getting intelligence, then we have already won the lottery. We are the lucky survivors. But if the filter is ahead of us, then we are in grave danger. Maybe the filter is technology itself. Maybe every civilization that discovers nuclear power or artificial intelligence inevitably destroys itself within a few centuries. Maybe the silence of the sky is not because there is no life, but because civilizations burn out like matches in the wind before they can say hello. This would explain why we hear nothing. We are listening to a galaxy of short-lived sparks, missing each other in the darkness of time. But there is a darker, more chilling possibility. It is known as the dark forest theory. Imagine you are a hunter walking through a dark forest at night. You know there are other hunters out there. You don't know if they are friendly or hostile. You don't know if they have guns. What is the rational thing to do? The rational thing is to stay silent, to step softly, to hide your light. Because if you reveal your position, you might be shot. In this view, the universe is a dark forest. It is full of civilizations, but they are all hiding. They are all listening, terrified that if they make a sound, a predator civilization, one that views all other life as a threat, will come and wipe them out. In this scenario, we humans are the foolish child walking through the woods shouting, "I am here! I am here!" We are broadcasting our location to the stars with our radio and TV signals, unaware that the silence of the older civilizations is not emptiness, but camouflage. There is a strange comfort in the dark forest theory, despite its horror. It means we are not alone. It means the universe is full of life, just cautious life. But there is a fourth option, one that circles back to the ideas we explored in the previous chapters about simulation and consciousness. What if advanced civilizations do not expand outward? What if they expand inward? We assume that a super-advanced species would want to conquer the galaxy, build spaceships, and plant flags. But that is a very human, very biological drive. We are driven by scarcity. We need land, resources, energy. But what if a civilization reaches a point where they can upload their minds into a computer? What if they can build a virtual reality that is richer, more beautiful, and more perfect than the physical universe? In a simulation, you can control the laws of physics. You can live forever. You can experience anything. Why would you bother with the cold, dangerous, slow universe of matter? Why would you spend 10,000 years flying to a dead rock in a metal tin can when you could create a paradise in a microchip? This is the transcension hypothesis. It suggests that advanced civilizations leave the physical world behind. They retreat into dense, microscopic computing structures, perhaps powered by black holes or neutron stars, and disappear from the visible universe. They don't go to the stars, they go into the code. They become the ghosts in the machine of reality. If this is true, then the silence is not empty. It is just running at a higher frequency. The galaxy might be buzzing with thought, but it is internal thought. The civilizations are sleeping, dreaming in digital heavens, while the physical universe grows weeds around their servers. We are looking for stone castles, but they have moved into the cloud. And then there is the zoo hypothesis. This is the idea that they are watching us. They know we are here. They have seen our radio waves. They have seen our atomic tests. But they have a prime directive. They treat Earth like a nature preserve. They are letting us evolve on our own without interference to see what we become. We are the uncontacted tribe of the Milky Way. Our isolation is artificial. the silence is a quarantine. Perhaps they are waiting for us to mature. Perhaps they are waiting for us to stop killing each other. Or perhaps they are waiting for us to signal that we are ready to join the galactic internet. This brings us to a profound question about the nature of communication. We listen for radio waves because that is what we know. We invented radio 100 years ago, but radio might be a primitive technology, like smoke signals. Maybe looking for radio waves from an advanced civilization is like looking for smoke signals from a modern city. They might be communicating with neutrinos, or gravitational waves, or by modulating the light of stars, or via instantaneous quantum entanglement networks that we haven't even discovered yet. We might be standing in the middle of Times Square, blind and deaf, thinking the world is silent because we can't hear the drums. Whatever the answer is, the silence forces us to look in the mirror. It forces us to grow up. If we are alone, then we are the custodians of meaning. We are the universe's only way of knowing itself. We are the keepers of the flame. Every piece of art we make, every scientific discovery, every act of kindness is a defense against the void. We represent the universe waking up from a long, dreamless sleep. If we die, the universe goes back to being a physics problem with no one to solve it. But if we are not alone, if the dark forest is full of eyes, then we are on the verge of the greatest discovery in history. We are children standing on the shore of a vast ocean, waiting for the first ship to break the horizon. And maybe, just maybe, the ship is already here. There have been unexplained signals. The wow signal in 1977, a 72-second burst of radio waves that came from the constellation Sagittarius and never repeated. The fast radio bursts that pulse from distant galaxies with mathematical regularity. The strange object Oumuamua that tumbled through our solar system in 2017, looking like a piece of technology and accelerating as it left. Were these breadcrumbs? Were they doorbells? As you lie in the dark, think about the signal that your own brain is emitting. You are a biological machine generating an electromagnetic field. Your thoughts are patterns of energy. In a way, you're a lighthouse too. You're signaling your existence to the room, to the people you love, to the world. And even if the stars never answer back, the act of asking the question changes us. It makes us look up. It makes us realize that we are crewmates on the same fragile ship. The silence of the universe is the loudest call to unity we will ever hear. It tells us that, for all practical purposes, we are all we have. We have traveled a long way together. We started with the neurons in your brain. We moved to the cosmic web, the fine-tuned laws, the quantum ghosts, the river of time, the black hole monsters, the beams of light, the dark ocean, the symphony of strings, and the heat of the last fire. We have looked at the universe from every angle, from the microscopic to the macroscopic, from the physical to the mathematical. We have seen that reality is stranger, more beautiful, and more interconnected than we ever could have imagined. But there is one final step, one final layer to the onion. We have asked what the universe is and how it works, but we haven't truly faced the who. We haven't talked about the ending of the story that includes you, not as an observer, but as a creator. We need to close the loop. We need to understand that the journey we have taken is not a straight line, but a circle. The mystery of the cosmos is not out there. It is in here. In the final chapter, we are going to bring it all home. We are going to talk about the cosmic self. We are going to dissolve the boundary between the dreamer and the dream once and for all. We are going to leave you with a thought that will change the way you wake up tomorrow morning. We are going to finish the script, but we are going to open the door to an infinite sequel. So, listen to the silence one last time. Really listen to it. It is not empty. It is pregnant with possibility. It is the sound of a universe holding its breath, waiting for you to speak. You are the voice of the void. You are the echo. Speak gently. Have you ever looked into a mirror, stared deeply into your own pupils, and felt a sudden, vertiginous shift in perspective? For a fleeting second, the familiar face looking back at you becomes a stranger. The name you call yourself sounds like a random collection of sounds. The history of your life feels like a story you read in a book long ago. In that moment of dissociation, the mask of your personality slips, and you are left staring at the raw, naked awareness that lies underneath. It is a frightening sensation, but it is also a doorway. It is the same doorway we have been circling for this entire journey. We have traveled to the edge of the event horizon. We have ridden the beams of light from dead stars. We have listened to the silence of the dark forest, and we have dissolved the solid world into vibrating strings. But all of these journeys have been leading us back to the most mysterious place of all, the center of your own being. Tonight, in this final chapter, we are going to cross the last threshold. We are going to dissolve the boundary between the dreamer and the dream. We are going to discover that the universe is not a place you live in, but a thing that you are. And we are going to realize that the silence you hear when you close your eyes is not the silence of emptiness, but the silence of the universe, waiting for you to remember who you really are. We are born with a very specific, very convincing illusion. We feel that we are separate entities, enclosed within the bag of our skin. Inside the skin is me, my thoughts, my feelings, my biology. Outside the skin is the world, the air, the ground, the stars, the other people. We navigate life as if we are pilots driving a biological vehicle through a foreign landscape. We speak of coming into the world as if we arrived from somewhere else, dropped onto this planet like paratroopers. But this is a linguistic and a psychological mistake. You did not come into this world. You came out of it. You grew out of this planet in exactly the same way that a leaf grows out of a tree or a wave grows out of the ocean. You are not a stranger here. You are a symptom of the earth. You are an aperture through which the universe is observing itself. Let us look at the physics of this connection one last time. We established early on that every atom in your body was forged in a star, but the connection is more active than that. You are a continuous process of exchange with the cosmos. You are breathing. Every time you inhale, you are pulling the atmosphere into your lungs. That air contains nitrogen, oxygen, argon, and traces of stardust. It enters your blood, becomes part of your cells, and powers your thoughts. When you exhale, you release carbon dioxide, which is then taken up by the trees and the grass. The boundary between you and the air is not a wall. It is a revolving door. The water in your blood was once in the ocean, once in a cloud, once in the ice of a comet. The heat in your body is the energy of the sun, captured by plants and transferred to you. Physically, there is no place where you end and the universe begins. It is all one continuous, flowing field of energy. The skin is not a barrier, it is a bridge. But the illusion of separation is stubborn. It is generated by the ego, the software in our brains that says, I am the thinker. The ego is a useful tool. It helps us survive. It helps us organize our lives, remember our appointments, and protect our bodies. But it is a terrible master. It convinces us that we are small, isolated, and fragile. It creates the fear of death because it believes that when the body dies, the I disappears. But if we look at the universe through the lens of what we have learned through quantum mechanics, through relativity, through the mathematics of the infinite, we see a different picture. We see that the specific form you currently inhabit is temporary, yes. The wave will crash on the shore, but the water, the substance, the energy, the consciousness is eternal. Consider the metaphor of the ocean again. A wave is a distinct phenomenon. It has a height, a shape, a position, and a lifespan. You can point to it and say, there is a wave. But the wave is not a separate object. You cannot take a wave out of the ocean and put it in a box. The wave is the ocean waving. It is a specific activity of the water. When the wave crashes and disappears, the water does not die. It simply returns to the stillness of the deep, ready to rise again as a new wave, perhaps in a different place, with a different shape. You are a wave. I am a wave. The stars are waves. We are all temporary, beautiful, unique risings of the same underlying ocean of existence. This is not just poetry. It is the implication of the unified field theory that physicists are chasing. If string theory is correct, and everything is made of the same fundamental vibrating strands, then the difference between a person and a rock is just a difference in complexity and frequency. We are all made of the same fabric. The cosmic self is the fabric itself. It is the silent, dark, infinite potential that births the galaxies and the minds that study them. When you say I, you are referring to your name and your history. But deep down, beneath the name, beneath the memories, beneath the personality, is the pure feeling of I am, that feeling of presence, that feeling of awareness. And here is the secret. That feeling is exactly the same in you as it is in me, and as it is in a cat or a bird, or perhaps even in the slow, magnetic thoughts of a star. The I is the universal constant. It is the one eye looking out of billions of different windows. This resolves the loneliness of the Fermi paradox. We looked for other civilizations and found silence. We felt abandoned. But if consciousness is singular, if we are all expressions of the same one mind, then we are never truly alone. The silence is the sound of our own unity. We are the universe playing a game of hide and seek with itself. It hides in the darkness of matter. It forgets itself in the complexity of biology. And then, through the eyes of a scientist or an artist or a mystic, it wakes up. It looks in the mirror and remembers. Oh, it says, it was me all along. This realization brings a profound sense of peace, but also a tremendous responsibility. If we are the eyes of the cosmos, then it is our job to see. It is our job to witness the beauty that the universe has spent 13.8 billion years creating. We are the sense organs of the infinite. Without us, the universe is a theater playing to an empty room. The grandeur of the Orion Nebula, the elegance of the spiral galaxies, the drama of the black holes, none of it is fully real until it is perceived. We give the universe meaning. We turn the math into awe. We turn the photons into wonder. This is why your curiosity matters. This is why your late-night questions matter. Every time you learn something new, the universe understands itself a little better. And this perspective transforms how we handle our daily lives. When you realize you are the universe, the petty anxieties of the ego begin to fade. You stop worrying so much about status, about approval, about the future. You realize that you are supported by the same laws that hold the planets in their orbits. You possess the same resilience as the stars. You carry the same fire as the Big Bang. You are not a small thing fighting against a big world. You are the big world expressing itself as a small point of focus. You are the vessel of the divine. This does not mean life becomes easy. The universe is violent. It is chaotic. It is full of entropy and decay. We still feel pain. We still feel grief. But we can hold these feelings in a larger container. We can see them as the necessary shadows that define the light. We can accept the impermanence of our lives with the grace of a sunset. We know the sun will set, but we also know with absolute certainty that it will rise again. As we come to the end of our journey, I want you to return your attention to your breath. Inhale, exhale, feel the rhythm. That rhythm is the oldest thing in existence. It is the echo of the expansion and contraction of the cosmos. It is the oscillation of the strings. It is the heartbeat of the dark energy. You are alive. You are here. You are conscious. And that simple fact is the greatest miracle of all. We have traveled far together. We have looked into the brain and seen a galaxy. We have looked into the galaxy and seen a mind. We have touched the edge of time and the bottom of the ocean. We have screamed into the void and heard the music of the spheres. And now we find ourselves back where we started, in the quiet of the night, in the safety of the bed. But the room is different now. The darkness is not empty. It is full of potential. The silence is not lonely. It is the presence of the infinite. The journey of discovery is an infinite loop. There is always more to learn. There is always another layer to peel back. The science will change. Our theories will evolve. New telescopes will reveal new mysteries. But the fundamental truth will remain. You are the universe experiencing itself. You are the mystery that you are trying to solve. So, tonight, as you drift off to sleep, let go of the need to understand everything with your intellect. Let the mind rest. Let the ego dissolve. Sink back into the ocean. Trust the water. You're not a drop in the ocean. You are the entire ocean in a drop. You are the stardust. You are the light. You are the silence. And when you wake up tomorrow, remember this feeling. Look at the world with fresh eyes. Look at the sky and say hello to yourself. Look at the trees and recognize your family. Walk through your day with the quiet confidence of a galaxy spinning in the void. You are the keeper of the flame. You are the guardian of the wonder. The story does not end here. The story never ends. It just changes tempo. It just moves to a new movement in the symphony. Sleep now, my fellow traveler. The universe is tired, and it needs to rest its eyes. We will explore again. We will wonder again. But for now, peace. For now, silence. For now, the beautiful, dark, velvet sleep of the cosmos.